development. Now let's welcome one of the organizers for the forum, the president of Flying Pages Germany, and also my old partner, Mr. William Peck, to address the audience. Let's welcome. Representing the organizer to address the opening remark. Let's welcome. We have bilingual translation. If you need the devices, please get it at the entrance. Yeah.
So if you need a translator, you can take out of the door. Thank you.
Yes. Great to be back here again. Like I know Kunshan now already several years, and it's always a very warm welcome. With the demonstration of Autoflight Changfei we had yesterday, I think it's really a highlight in what the e-flight industry and the low altitude economy is achieving. And yesterday it was really, some people told me, now you see it's really moving. It's not only anymore R&D or computer animation, it's real aircraft flying. There are real people watching, and I'm looking forward that fairly soon we also will have real people inside the real eVTOL aircraft flying around on a regular basis. One of the goals of this forum was always bringing the people together. That's why I really have to thank all my Chinese hosts here, so the mayor and the city of Kunshan, the government which is supporting us, Ms. Chen, she's doing a great job for us for organizing this here, and all the international guests which are coming as well, because this is my key point here. I think we still really have to work together internationally. It's not one country who can achieve this. Low altitude economy, eVTOL, electric flying, sustainable flying. This is a global challenge, and that's why I'm proud that we got, despite the challenging times we have now, guests from United States, like the Lama President Scott Severin, guests from Australia, from France, from Germany, from Switzerland, and sure, local guests from China. So I think it's great to have you all here. I see that we are already a little bit behind the schedule, so I make my speech short, as I will have time to speak later in the sessions. So please enjoy the new technology and the new inspiring ideas we bring to you, and stay tuned and participate also in future in our forums we do. Maybe come over one time to Germany, to the e-flight Expo, where we had the first forum already in 2009, and which is running every year in Germany, Friedrichshafen, in springtime. So maybe if somebody of you wants to travel to Europe, that's a good time because you can combine it. And with this, thank you, and let's get started.
Based on the schedule, the co-host, I'm the Chinese host, and William is the foreign host, and we'll guide the guests to present to the audience. As Willi just mentioned, the e-flight is a good opportunity for the global aviation industry. It is also a challenge we jointly face. I want to pay special tribute to international guests. We have guests from Germany, Australia, France, the US, etc. We now move to the final item for today's opening ceremony. Let's welcome a member of the Standing Committee of the CPC Kunshan Municipal Committee and Executive Vice Mayor of Kunshan, Mr. Qian Xudong, to deliver his remark. distinguished Mr. Li, Xiaojie, Mr. Yang, all the guests, all the leaders, and all the friends, good morning. It is my honor to join with you in Dianshanhu Lake to jointly participate in the 9th e-flight forum. As mentioned by the moderators, the forum has been held in Kunshan for 4 years in a row. It is my honor to participate in the forum for 4 years. I personally witnessed the Kunshan LAE with the empowerment of the forum has been further development. So I want to represent the Kunshan government and CPC committee to express my heartfelt thanks and congratulations and to all the guests and to the opening of the forum. I also want to say thank you to all the people who support the socio-economic development of Kunshan. Thank you all. In recent times, the 15th five-year plan and clarified that we need to accelerate the new energy, aviation, astronautics, and aeronautics, and LAE emerging industry development. Due to our early deployment in the LAE as an emerging track, LAE has been incorporated into the 2+3+3 industry system of Kunshan. So we anchor the Advanced Manufacturing Center for LAE in Yangtze River Delta. For developing LAE in particular, the e-flight industry, we have more confidence and we are stronger in development. So the confidence stems from the vigorous Kunshan economy. As a representative of the county economy, Kunshan GDP has been surpassing 500 billion RMB. And for the industrial output for 4 years in a row exceeding 1 trillion RMB. Export-import exceeded $100 billion for 4 years in a row. This year, for 21 years in a row, we were awarded the top 100 counties in China. We ranked the first. Now, due to uncertainties in the world, the first 3 quarters economy in Kunshan still maintained momentous growth, 6% of growth. So the vigorous Kunshan economy are full of vitality. For the high-quality projects of LAE, choose Kunshan and settled in Kunshan. At the same time, I think the confidence is from the comprehensive ecosystem of industries. In the video, you may have seen that the Autoflight and Shidai Fengpeng and all these companies are leading the way. Kunshan has integrated the whole supply chain, more than 100 companies in the aviation industry with more than 10 billion RMB in total output in the industry by building the Green Industrial Park and also the LAE Park in Kunshan. We have the civil trial and the test operation base in Kunshan and also the eVTOL testing manufacturing capacity delivery base in Kunshan. We regularly held the exchange meetings of the drones and head company exchanges to leverage the funding and to boost the development. So we have the long supply chain and the wide radiation LAE ecosystem, in particular in the scenarios part. Now the Kunshan, the drone inspection and has been one new normal, and the 3 minutes the drone food delivery and parcel delivery has been put into operation. In the future, we'll cultivate more scenarios and to open up new application of larger scope scenarios. We welcome all the companies join us in the breakthrough technologies, scenario verification, and upgrading the systems. Finally, this confidence is from the empowerment and from all of you. In the process of industrial development, we not only gained the support of NDRC and also the CAAC, but also we gained the support from CSAA, etc. In the process of the forum, and we have known a lot of experts and the blockbuster professors and experts from the industries, and due to empowerment, we're more confident. I sincerely hope that all the guests and leaders can support and care about Kunshan so that you may contribute to the LAE development and to give us guidance and support. We sincerely welcome all outstanding enterprises and top-tier teams and go into Kunshan and to be settled in Kunshan to join with us to promote more emerging technologies and products from the lab to the production line, from the sample to people's life, so that the enriched applications can be translated into prosperous development. Finally, I wish the forum a success. I wish all of you good health and a successful career. Thank you.
好，感谢我们钱市长一直以来
Thank you, Mayor Chen, for your long-term and unwavering support to the forum. As you mentioned, Kunshan is indeed the prosperous land for LAE. We hope that more entrepreneurs can participate and pay more attention to Kunshan low-altitude economy development. I want to thank you again for your participation in the opening ceremony for the forum. Now we'll conclude the forum, the opening ceremony. Now I want to announce that the 9th e-flight forum is officially opened. We shall now enter the subject 1, low altitude economy, the MOSAIC rule of FAA, and the policy making. Let's welcome the first speaker from the CSAA Airworthiness Committee, Deputy Director Zhong Zhiyong, for the keynote speech. The topic is about introduction of regulation of UAV certification. A kind reminder that because we have so many speakers, please control your time within 15 minutes. Thank you. It is my honor to participate in this e-flight forum with the entrustment of the director for the committee. I want to share with you about the airworthiness management, the rules and regulations for the civil drones. The convening of this forum, including the LAE development in China, is supported by national policies. There are some milestone landmark policies and some of the time frame. For instance, in 2023 December, in the Central Economic World Conference, and we promote about the development of the LAE and other emerging industries. Currently for LAE, the opportunity and the window of development, there are 4 aspects. To start with, in terms of the policy environment, since 2023 up till now, for the drone-related regulations and the laws and the rules, including the procedure of implementation and the channels, have been issued by the government. The second is about tech environment. With LAE development, the drone technology has been applied in a constant manner. As we just see in the video, the auto flight, the e-aircraft can have the range of 200 kilograms. It was impossible to think about 10 years ago, so tech development is one opportunity for the LAE development. The third part is about the economic environment. A lot of capital and funding, they are now entering into the LAE for auto flight, with the CATL has become the largest shareholder. For the government, it is also the case. In this forum, we are supported heavily by Kunshan government and all the governments in terms of LAE forums and also the attraction of investment. Some new policies are issued.
And the last is the environment. Human always dream to fly into the sky, and we see increasing demand in this area. So I'll share 3 aspects with you today. One is the current landscape of civil UAV system industry. The second is low altitude safety and airworthiness certification, the rules and regulations. And the third is the regulations and standards for UAV airworthiness certification. By the end of September 2025, we see actually over 3 million UAVs being registered with 4,100 types. Comparing to manned aerial vehicles, this is not the same scale. If you look at the manned aerial vehicles, then it's less than 10,000 registered. Since the founding of PRC, we've only issued permits and licenses to 50 types of manned aerial vehicles. And of course, we have more applications, over 1,800 middle to large-sized UAVs. So in terms of UAVs, we now see different sizes of UAV, medium to large, large, and small, etc. So that means different regulations and requirements. This is the product structure of UAV. We have basically two types of UAVs. One is a fixed wing, and the other is a rotor wing. So you have ascendant driving force given to you by different structures. And we also have the vertical takeoff fixed wing and the tutor rotor. So vertical takeoff fixed wing have both merits. They don't have high requirements to the runway, while at the same time they also have the merits of motor wing or multi-rotor wing. Second part, I want to talk about low altitude safety and airworthiness certification. So low altitude safety management, well, first of all, refers to the system for the safety control of airspace under 3,000 meters, but it's not that strict. Perhaps 3,100 meters can also qualify as in this category. It's not a red line. It's just aircraft is managed in a different manner as to large cargo aircraft weighted 10 to 20 tons. And second, this is different to the civil aircraft aviation management. For instance, when we take those main lines, those lines are fixed, for instance, during the Spring Festival, and usually they take passengers or cargoes, but the UAVs, they are quite different, so they need to be managed in a different manner. The second is airworthiness certification. This is the technical entry threshold to ensure low altitude safety. This is like getting the production permit or license before you are allowed to manufacture anything. And we need to ensure that those UAVs are certified so that they do not pose any threats to people, property, or public order. Next is the regulatory standards for UAV airworthiness certification. You know that when departments and administrations give out rules, usually there are 4 layers. The first layer is the civil aviation law, and UAV is now under the management of civil aviation law. In 1996, we didn't have UAV during that period. And under the civil aviation law, we have the regulation on the flight management of civil UAV. And under that regulation, we have a rule proposed by Civil Aviation Administration, the regulation CCAR-92, and the other two, the rest two, are the standardized document, one for management, the other for technical details. For instance, under the regulations, we have procedures and circulars, including 3 APs, management-related APs, and 1 AC, covering real name registration, nationality registration, airworthiness certification, and classification and categorization. Also, we have the rest 2 sets of technical guidelines focusing on the management side of safety assessment, and 21-40 refers to the categorization and safety analysis. The last 2, as I mentioned, are the technical guidelines. For instance, for those mature UAVs, they haven't got the airworthiness certification yet, but they, in terms of type, they are quite mature. They have been verified, and would allow them to get airworthiness certificate before October 26 next year. And the next is the technical standard for mid-sized UAV, and that's the only technical standard for that type. You may ask, what type of UAV require airworthiness certification? Well, mid to large-sized UAV, they all need to get airworthiness certification. So from 25 kg to 150 kg, all of these UAVs need to get airworthiness certification. And for light and micro civil UAVs, they do not need to get a airworthiness certificate. However, they need to comply with relevant quality laws and regulations and etc. This is a comparison of administration approaches for UAVs and manned aircraft. So the 4 layers of rules and regulations for UAV are based on the rule structure of manned aircraft. We have a civil aviation law published in 1996, and so far it's been 30 years. So we have a rather complete rules and regulation framework for manned aircraft. For instance, the 21 different categories of airworthiness certification types, fixed wing, multi-wing, 21, 29, 23, and etc. We have those articles indicating the specific requirements. And in terms of the specific standards, some of the standards are still being developed. The real name registration of civil UAV have already been published, and the technical standards are pending development. And right now, when companies they need to apply for airworthiness certification, they need to apply to they need to apply to CAAC via a certain path. And this is the classification of UAVs and airworthiness models. So basically 2 types, limited use UAV and standard type. And we classify UAV that meet three conditions: unmanned, no entry into integrated airspace, and no flight over densely populated areas as a restricted category UAV or limited use UAV. If any of these conditions is not met, then they are classified as normal category or transport category. So far, 17 type certificates have been issued, and Dajiang has eight type certificates because their products been iterating rapidly, and other companies they have 1 to 2 type certificates. Yihang has got the TCP certificate, and others they all have the limited use UAV certificates. And we also have over 50 projects currently under review, so there's still a long way to go for us. So manned aircrafts are quite different to UAVs. One, they have different safety goals. When we did the system safety assessment, this is the first point we raised. So if it's manned aircraft, then crisis would lead to death and crash of the plane. But for UAV, it's different. Crisis would only be created if the UAV fell on the ground and hit any people. Also, the philosophy of UAV and UAV design are quite different. Many of those philosophies are from the tech industry, so they're different to traditional manufacturing. Also, the application scope are different. Forces different management approaches. Given the safety management, given the safety differences, the management of UAV are quite different towards manned aircraft.
Finally, some suggestions. To start with, we need to enhance the training and popularization about the drones airworthiness. We mentioned about the difference of airworthiness for the unmanned aircraft and manned aircraft. Secondly, the CAA structure reorganization. We need to build up the professional organization or institution, because for drones, the feature can be integrated with emerging technology. Therefore, in airworthiness about the motors, there can be some new requirements. Third is about the reconstruction of the rules and regulations. For the airworthiness regulations and laws for drones, it is in the process of improvement. Although we are leading already in the world, when I exchanged with some foreign friends, and they talked about the structure, not only about the airworthiness, but also about operation and the handling, etc. So in the process, we need to rebuild the laws and regulations. The fourth is about the reconstruction of the management method. As we mentioned, the type and the quantity of drones compared with traditional manned aircraft, it is not in the same magnitude. CAC is considering about authorizing the third party to do some inspection and verification for the industrial development, but to what extent we can delegate the power, that is still a question. Finally, it's about enhancement of research on emerging technologies, including the AI and the technology impact on the drones. We mentioned about the autonomous driving And AI, what will be the application scenario? For traditional AI, it is always about the data accumulation analysis, but for the AI in drones, how much they can be involved. About this, my introduction. Thank you for your listening.
I think, yeah, the mics are working here. So thank you very much for this interesting presentation, giving us a view of China and what's going on in China. You talked a lot about UAVs, and I think UAV is one of the big markets now. On the other hand, we've seen recently that there has been companies struggling, especially over in Europe, because the certification rules for manned aircraft are very challenging for getting somebody certified. In this subject, there was a new rule finalized coming out in the United States this year, and the United States is still the market in the world where you have the largest community of manned aviation flying. So the MOSAIC LSA rules can be kind of game changer for the eVTOLs getting into the air faster and getting us more data of more eVTOLs flying. That's when I was in States this year when the new MOSAIC rules were announced. I thought we must have somebody here who knows and who can tell us about this. And so I'm very proud that I could persuade Scott Severin, president of LAMA, because LAMA was one of the key creators of these rules. He is a president of the ASTM 37 committee. He will tell you a little bit more about this sooner. And I'm very proud because especially right now, this is a week before Thanksgiving, which is a little bit like you have the national Chinese holidays where it's very difficult to get executives to travel to overseas to give a presentation. So Scott, he's an old friend from hang gliding, from ultralight, from all kinds of flying. So Scott, welcome to the stage, and I'm happy to have you here to give us a glimpse of MOSAIC flying. Thank you.
Very good. Well, welcome, flight entrepreneurs, enthusiasts, and invited guests. I'd like to first thank Gao Yunyang and Willi Taki for hosting such an informative event, and now for the 9th time. It's wonderful to see this in China. And thank you to all of you for participating in this global event. Yes. Today, I'll provide a broad, high-level overview of MOSAIC. The big opportunity and trend in the regulatory environment is moving from CAA type certificated compliance to self-declarative compliance through industry consensus standards. Remember, self-declarative is where LAMA resides and where we do much of our best work. Type certification is cumbersome, takes a long time, which freezes advancements and finances. Self-declarative compliance is comparatively nimble, it's cost-effective, and adapts to new emerging technologies. MOSAIC stands for Modernization of Special Airworthiness Certification. First, here's the reasoning behind the whole MOSAIC process. An important concept at the FAA in the United States is the safety continuum. This is a principle guiding the agency's approach to regulating aviation safety. It moves away from a one-size-fits-all approach. This flexible framework allows the FAA to balance safety risks with the needs of the aviation industry and the flying public, while also encouraging innovation. Some points of this graphic. Increasing the scope of LSA enhances the tailoring but more prescriptive philosophy from FAA FAR Part 103. Part 23, I'm sorry. This is the type certificated world. This makes the safety benefits of LSA more accessible. LSA then can be an entry point for innovative technologies that can grow along the spectrum. You can see here the experimental operations down on the bottom in the United States. Many people can build their own aircraft and fly them. The light sport operations in the tan, and the standard recreational operations in the blue and transport. Over on the far side is a light, the beige box that says original LSA rules, which accommodated a little bit of the experimental and amateur built, accommodated a little bit of Part 23 airplanes, a little bit of novel aircraft, not too much, and didn't allow for helicopters. The expanded whiter box, you can see, brings in more experimental Part 23 airplanes that can now become light sport, novel aircraft, which is what we're very interested in today, and helicopters as well. And this is all because of MOSAIC. So how is light sport working so far? Really pretty well. You can see on the chart on the left, accidents per 100,000 hours. Amateur built safety is improving. Light sport aircraft safety is equivalent with type certificated aircraft. And this is one of the reasons why the light sport aircraft has been expanded in its scope to bring in much more capability. The chart on the right side is accident counts. Experimental and LSA have fewer accident counts than general aviation. This is expected as there are presently fewer LSA aircraft. The green line on the left chart needs to be at or below the red line. And because of that, we have MOSAIC. So let's understand the goals of MOSAIC. The primary goal is to revitalize general aviation through flight training, transportation and utility, personal and recreational use operations. The methods are bringing new technology in aviation through modular standards which will increase safety, write the minimum standard to increase simplicity, integrate the safety continuum balance, that is very important to the FAA, increase the safety over experimental to certified level 1 and level 2 standards, and introduce new aircraft types. To light sport now, rotorcraft, powered lift, eVTOLs, and emerging technologies, all involved in the low altitude environment. The ideas are to increase safety where the cost is low and the return is high, reduce costly, burdensome requirements where the return is low. Reduce the number of requirements. Every requirement takes time to show compliance with, which increases costs. Requirements can be CAA specific. There's no need that, there's no need for one CAA to have rules that would impact another country. ASTM industry consensus standards compliance, while much simpler than Part 23 certification, still is very thorough. We will not discuss all of these items one line at a time, but the point is that there is a lot involved to make sure new technology solves more problems than it creates. What MOSAIC does is make sure the process is simpler while maintaining safety, all of this while reducing costs. LAMA works together with associations and governments that affect change. Specifically, LAMA board members are voting members on the ASTM committees that create the standards for light sport aircraft and beyond. That's MOSAIC. LAMA is on the executive committee for the ASTM F-37 light sport. Here's a high-level look at what MOSAIC brings. A dramatic expansion of the LSA category, the addition of new FAR Part 22 for LSAs, no explicit weight limit. This is fantastic. A 61-knot landing speed stall for light sport aircraft, so with flaps extended, the new light sport aircraft can have a 61-knot landing stall speed. A 250-knot maximum speed. 4 seats are allowed. For a sport pilot airman, he can only carry 2 occupants in the aircraft. Multi-engine is allowed. Electric propulsion is allowed. Turbine propulsion is allowed. Powered lift is allowed. Variable pitch propellers are allowed. Retractable gear is allowed. Rotorcraft are allowed. Flight into IMC is coming. Night flight allowed for sport pilots with basic med, and an endorsement will be allowed. A note for clarification. In the United States, the sport pilot, the airman, is separated from light sport aircraft fixed wing, the flying craft. You will note that the LSA craft can have a landing stall speed with the flaps extended at 61 knots. However, the sport pilot, the airman, can only fly a light sport aircraft with a clean stall speed of 59 knots with no flaps. You'll see this throughout a few areas in the MOSAIC where there's a definition from the sport pilot airman and what privileges that person would have versus the light sport aircraft, which is widely expanded over the current light sport rule. As multiple aircraft types are considered, various factors may be applicable, such as higher inertial load factors for impact, 5-point harness, additional seat loads, including the connection of the seat to the structure, clear zone in front of the occupants, chamfer on lower forward firewalls or skid plates, turnover testing, egress testing, forward fuselage upward impact load tests, and other small items for Part 22 compliance. Other items of note with MOSAIC, third-party alterations will be allowed which haven't been supported by the existing rule. Additional electrical requirements will be coming up for the new MOSAIC aircraft. Flutter requirements, including dive testing, GVT and audio warnings. Angle of attack will be required. Aerobatics, indirect flight controls are coming in now. Software and firmware. There are noise considerations that will now be applied, and propulsion types, as we mentioned, from turbine to electric to whatever has not been developed yet. There are 2 important dates, April 17th and July 26th of 2026. There's a process that has to occur for MOSAIC compliance to be complete. 9 months after the final MOSAIC rule was published, the ASTM standard should be completed. That target date is April 17th of 2026. On April 17th, or before, although that's not likely, the ASTM will submit their completed standards to the FAA. Typical processing time for the FAA can be several months to a year or greater. However, the FAA wants to fast-track this program. On the same side, the FAA needs to make sure that anything in the ASTM standards does not conflict with the departments within the FAA. So this has to go through FAA legal, medical, flight standards, airworthiness, to make sure there are no conflicts between departments. In meetings we've been having with the FAA, it sounds as though 3 months will be a reasonable time as they fast-track this. So once the standards are accepted by the FAA, manufacturers can declare compliance to the new standards and start selling new aircraft. That date we're looking at should be July 24 of 2026. That comes out to 169 working days to get the suite of standards completed for FAA acceptance. We have a lot of work to do. And so do I, apparently. The faster the standards are created and amended and then accepted by the FAA, the faster new LSA can be sold. Manufacturer and consumer engagement with the standards development will drive this. This means that anyone here or around the planet can participate and make a difference in when the new LSAs are available. You can do this by joining LAMA and ASTM. You can make this all happen more quickly, and you don't have to be an engineer. The more people that are involved, the sooner the new standards will be completed. If you want to see LSAs faster, scan the QR codes on the left for LAMA and on the right for ASTM. Those of you that want to be involved in ASTM and help develop the standards to show compliance with the new regulation are invited to work with either one of these associations. LAMA guides policy, and ASTM creates the standards, which are all created by you all and us as participants and manufacturers in the industry. Here you can get access to the final MOSAIC rule. As a matter of public interest, there were 1,315 comments to the rule when it was published in the Federal Register. Only 11 comments opposed the rule. I hope this has been informational to you all. Manufacturers join LAMA to influence appropriate rulemaking and create the standards for our industry. Membership provides resources for LAMA to shape policy and regulation. It's my hope to add eVTOL, low altitude, and these emerging technologies to more formal LAMA groups and committees. Thank you all for your attention. I know these are complex issues, but we all have this disease called aviation. It's in our blood. Sometimes it takes a lot of work to stay healthy, but together I'm sure we can do that. Thank you very much.
谢谢Scott。
Thank you, Mr. Scott Severin. Very excellent presentation. So MOSAIC now has a big change. We know that lots of the LSAs fall under the management of MOSAIC. MOSAIC, well, the US has already got a rather sound regulation framework. Well, China could certainly borrow a lot from the US, and perhaps it's easier for China to start drafting its framework than the US repairing or completing its framework. I noticed that the weight limitations been removed from the new policy. I'm a bit surprised to see that. So we will certainly closely follow the development of the new rules. Thank you very much, Scott. And next, we'd like to invite Xu Mo. And Professor Xu will talk about the technical side and the technical side of manned aircraft. Manned lifting manned power lift. I'll cover several aspects. The background to vertical takeoff and landing, powerful motors and batteries, and system security, and etc. We all know that right now we are very interested in powered lift aircraft. We have done quite a lot of discussions around this topic. And it has two features. One is vertical takeoff and landing. The other is the aerodynamic performance of the wings. So they need to meet these two conditions to be qualified as a powered electric powered aircraft. Right now, we have seen more attention being paid into the sector. We hope this aircraft can be more economical, comfortable, and technologically safe. So about true vertical takeoff and landing, I'd like to address this from several perspectives. One is ground effect hover takeoff and maximum wind resistance capability. Also, from that, we would need to have more technical capabilities to measure wind farm and to monitor the equipment. In terms of ground hover takeoff, well, in the past, we would need a high starting point. So first of all, it would require a high starting point for takeoff, and that means they have excellent obstacle clearing performance. In terms of vertical takeoff and landing, as you can see the picture at the bottom of the page, so the key part is number 1 and number 10. So they need to have a takeoff and landing with a high enough level. So these two processes, vertical takeoff and vertical landing, they have different technological requirements. So comparing to traditional terrain and surrounding areas, and comparing to traditional aviation airports, the wind conditions here are more stable and more complex. And that means we need to monitor the wind farm and use specific equipment to do that. Usually for general aviation airports, the 10-meter wind speed measurement would be enough. But now For eVTOL, we would require maybe 100 meter wind speed measurement. So the calculation method, the measurement method, and the estimation method are both different. So we could use a millimeter wave radar to help us to do that. And that method can cover area with 600 meter diameter and a level as high as 1,000 meter. Another thing we need to focus on is the performance change, critical dynamics, their ability to overcome obstacles, and especially during takeoff and landing phases. Again, this picture, the left number 1 and the turning point number 2 are our focus. This is the highly challenging area. From number 1 to number 2, we have the critical dynamic changes. We can suspend the takeoff, and on the right we have number 10 and the turning point number 9. From 9 to 10, from hovering to landing, we will also see a critical dynamic change. So the climb and lift transition and retransition performance must be able to reach certain point so that the flight wouldn't fall off, wouldn't fall down. Also, the terrain and the ground conditions are more complex than general aviation and traditional aircraft. Also, the operator, they need to develop their own flight plan based on the performance data and the obstacle assessments. We need to make sure the aircraft can hold on at certain phases. So the power of the electric motors used for takeoff and landing also need to reach a certain point. When the critical engine fails, the power budget for the remaining engines need to increase to a value greater than the takeoff power.
For this part, we can refer to traditional large aircraft and the two standards. One is ATTCS, another one is OEI. We can take these two standards as reference. As we just mentioned, we need to have the heart, namely the power. So for the e-powered lifting aircraft, so some of the mainstream and top enterprises in China, we are adopting the electric power. In the future, we may have the hybrid power or more methods of power sources. Now the main styling is using the distributed arrangement, so the number of motors has increased a lot. Yesterday we talked about the 10 rotors and the 3 propellers. So for another company which is called Aerofugia, it requires 8 motors. So the one motor, the weight is not high, but multiple motors in combination, the weight may account for the high percentage. For the battery, the power intensity now, we're still facing some bottlenecks of some constraints, and so the battery also accounts for some weight. They together account for more than 50% of total weight. Apart from the performance and the functionality, mentioning about the payload and no matter the passengers or cargo, economic concerns is important. Now we talk about the LAE and not only about low altitude but also economical. So it is quite important to get the cost down. So no matter for the motors and the batteries to make it stronger, lighter, smaller. That is a directional mission for the industry. The current status is more than 2 tons of the power lifted aircraft. We need to have more than 500 kilograms of payload. That is feasible. So initially, the payload may be lower while ensuring safety. We can gradually, based on the performance enhancement, to extend the range. For the systemic safety based on the operation intensity, for a lot of practitioners, we have consensus already. Under different systems, they adopt different safety indicators. We don't need to read into the PowerPoint. In the PowerPoint, we can see from FAA and ESA, some of the requirements are higher, namely the 10, the -8. But for some the CAA, there is the single disastrous systemic failure possibility needs to be lower than the 10 powers of -8. That is quite different. So for us, for practitioners, that is quite confused, the requirement. Now in China, for LAE, development has been quite prosperous, no matter the industries or the government. The consensus is that to start with, we focus on the low intensity operation based on higher technology. We can incorporate the higher intensity operation to have the distributed method of development. Final part is the noise. Talking about green development, apart from the form of energy, we always talk about noise. It can be a specific topic for discussion. And for instance, we can make the in-cabin environment quieter. That is one necessity for passenger aircraft. We know that helicopter, the noise is kind of high. We need to put on the specific earpiece. For commercial aircraft, we don't need to put on the earpiece to avoid the noise. So for this type of the power-lifted aircraft or eVTOL, we hope that when we sit in the cabin, the quietness requires no earpiece. We can talk freely. We can get comfortable experience. With the tech advancement, we consider that it will be better. For instance, the rotor, the propeller, the aerodynamic noise reduction design, that is one pursuit. What's more, from the materials, we can have some isolation of the noise, lowering the vibration, and also to have the insulation method, etc. Thank you. Finally, I want to say that we are now focusing on the eVTOL, no matter for the standards or for the proof operation. The precondition is that based on the technology and how can we make improvement. So the technology, we need to have the joint consensus. We hope that we can have the down-to-earth attitude on technology to put in more efforts. Thank you.
Thank you, Ms. Xu Meng, for this detailed presentation. And as next guest, you really see we jumping around the world. Next guest, we have Emmanuel Davidson from France. And he is not only a pilot since 1999, and he's a air traffic ATP, so it's a commercial pilot's license. He's also president of AOPA France, and in this position, he has doing a strong support to EASA on safety in air traffic, because this is one thing we talked a lot already about having this new aircraft, having this aircraft certified, but at some point when the aircraft should be useful for man, they have to be operated, and they have to be operated in space where is already aviation existing. And this is his subject, getting safety in these operations. And just a quick remark, he's also not only a long friend, but also my partner in doing the publication, which you can receive here at the desk, the World Directory of Light Aviation. And if you want to get more into the world of this kind of aviation, from eVTOL to existing aircraft, have a look in there. It's in German, English, French, and Chinese. Thank you very much, and welcome, Emmanuel.
Well, first of all, it's really nice to be back here, and it's always a privilege to be presenting here. As Willi said, my name is Emmanuel Davidson. I'm a pilot, and I work on various working groups at EASA. With all one point in common is how we're going to share the sky in the future. So this presentation might be a little bit more technical than the previous ones. So hang on with me and let's go through it. As you can see, there are many different types of aircraft now sharing the exact same sky. And those are gliders, jet, balloons. The drones are coming in number, eVTOLs, ultralights, helicopters, general aviation. So that's a lot of people in the same sky. So airborne surveillance obviously is something that is really important because ATC must make sure that planes do not come and collide with each other. And with the increased traffic in the sky, it becomes more and more of a challenge. So until now, we have relied on transponders and SSR systems, radars on the ground, to detect the aircraft. And ATC's role was to talk to the different aircraft and to deconflict them, tell them, okay, you need to take 10 degrees to the right, you need to climb, you need to descend, let's make sure that nobody collides. And obviously, with this technology came the last line of defense for commercial aviation, for airliners and business aviations, which is the TCAS system. And basically, those systems in the plane will interrogate the various transponders around them, and that will end up by saying, oh, there is an aircraft, so it works aircraft to aircraft, not from the ground to the aircraft. And it will give orders to the pilot in case two planes come too close. It will give some advisories, say climb or descend to one of the planes, and the contrary to the other one. Those are archaic solutions, and they're not really to the technology, responding to the technology we have today. So we know that today we're going to ADS-B, the Automatic Dependent Surveillance Broadcast System, which is the new standard. Now in the US, since the 1st of January 2020, it is mandatory for any aircraft in controlled airspace to be broadcasting ADS-B or another system which is equivalent for general aviation. This system works, it's the best of both worlds because ground stations and the equivalent of radar will receive information from the planes. So ATC has the vision of everything that transmit ADS-B, and it works in between two planes. So if two planes come close to the other, they will talk to each other directly, which is much better than a system that goes only by the radar and goes only by the ground. But of course, there is also general aviation and recreational aviation. And new technology has made some big progress there. So FLARM is a system that was invented in Switzerland. And it's based on a small GPS and a small transmitter using a public use frequency, radio frequency. And it's mostly used on gliders. There are more than 50,000 gliders equipped in Europe for the moment. And the system in the glider just broadcasts their position, their heading, and broadcasts that to any other FLARM system that is within reception range. So suddenly in the cockpit, you see when you're flying a glider, you can see the other gliders around you and make sure that you don't collide. It's a very cheap system. It's a very efficient system. It's not for all the aircraft, but it works very well. And we have multiple other technologies like this that work very, very well for their niche market. The problem is that if you have a transponder mode S or mode C, TCAS will see you. If you have FLARM, TCAS will not see you. So in the end, with all the drones coming also in the low altitude system, we're in desperate need for a unified system that will make all traffic visible air to air and ground to ground. So I won't bother going through all these. All the presentations are available to you after those sessions, so you can go into the details. But we just listed the problems we encounter with each system and why there is no universal system at this point. Now imagine, just imagine for a second that we do in aviation what we have done with internet. We've got multiple data sources that are available, and you can access them all through the same network. And basically, you can get to the data you need without bothering to know really what technology you're using. And that's exactly what we're advocating for the future of aviation, is that we take the source of data for the drones, the source of data for eVTOLs, we take civilian radar, the SSR system, we take ADS-B, and we all put them together and rebroadcast that from the ground to the aircraft. And that way, we will have a complete vision of who's in the sky, where, going where, and making sure that we don't collide. You have to understand that for the moment, we have no real vision of what's going on up there. EASA, 3 years ago, was under the opinion that we had about 20 to 30 occurrences of near miss of aircraft in Europe. With a Belgian company called SafeSky, we actually uploaded all the historical data of all the transponders, SSRs, FLARM, and all different systems, and created one gigantic database where we could run queries. And we said, okay, in France, for the month of August 2023, find all the occurrences where 2 aircraft, whatever the categories, came at less than 500 feet horizontally and less than 200 feet vertically. Can you guess how many occurrences we found for 30 days of historical data? 230 in France only, not in the whole of Europe, just in tiny little France. 230 occurrences. EASA was like, what? Of course, we couldn't know before because the systems were not talking to each other. So we had to put everything into the same database to be able to understand what was going on. And that's how we understood how important it was to migrate to a better SSR and surveillance system. So it's of paramount importance that all aircraft, drones, balloons, gliders, helicopters, share a common technology allowing them to see each other and to be seen from the ground so that ATC can continue to fulfill their role. We really feel that this is really important, and there is a technology that allows that and give additional benefits. UAT, which is kind of ADS-B, but using a special frequency, where we can upload all the traffic information to any type of aircraft, and it also allows us to upload weather information. So, for instance, where the thunderstorms are, all the data that is necessary to conduct flight safely for the pilots can be uploaded for free directly to the planes. We can even send a message to individual planes because we know who they are, so we can say, oh, send a little text message to this plane, and it will appear on the screens or on the tablet of the pilot in that plane. So that's what we're advocating for the future. It's not a win completely, but we're getting there. It's moving forward, and I think that everybody understood the paramount importance of being seen by everybody and to be able to see all the other traffics in the sky. So that's really the new challenge, sharing the sky. Thank you very much.
Thank you, Mr. Emmanuel. He is a pilot, and he's also done quite a lot of research in this area. So, be it the format of the aircraft, eventually we are flying in the same sky. So, how to manage the safety of these aircrafts? You need a common platform. This is also an important topic. In China, yesterday I was in Hunan attending a forum on low-altitude economy, and they talked about all sorts of technological proposals. Some are based on GPS, 6G, 5G, and eVTOL, but there's no common technological framework. So I believe now is the time to align the standards so as to solve the communication problem between aircrafts and between land to sky. So thank you, Mr. Davidson. And next we'd like to invite Hou Xiaoyu from Airworthiness Certification Center of CAAC, the Deputy Director of the Center, to share with us research on domestic common technologies and chip certification solutions. We also have tea and refreshments outside, but in the interest of time, we won't have tea break. Feel free to fetch the snacks if you like. Hello, everyone. Thank you for the opportunity. And today I'll share what our center has done on the research in domestic common technologies and chip certification. I will talk about three things: research on domestic technologies, chip certification, and summary and outlook. Right now, we are facing several issues. Our civil aircrafts are making breakthroughs. Low-altitude economy are developing rapidly, while at the same time, we see geopolitical and geoeconomic issues. We see the rapid integration of air transport and aerospace manufacturing industries. We are now facing lots of new challenges. One is we have significant projects now, and we have lots of them being domestically made. And also we see increasing emerging technologies. However, we have limited reviewing resources and very tight project timelines. So these 3 more and 2 tight are the new norms, and this is a critical issue. We must address this issue to ensure aviation safety and achieve the development of aviation industry. So to support this, our center established a dedicated leadership structure and working mechanism. So under the leadership team, we have a special task forces and a third layer special teams. We have invited departments, academic institutions, airliners, and testing organizations to join us to conduct the work together. And so far, we have 36 organizations, 400 plus experts. And together, we are developing the standards and rules and regulations. The first batch of achievements shall be published by the end of this year. So for the first phase, we focus on 3 types of standards. The first is the currently missing standards, and we mainly want to cover the currently blank areas. The second is the standards disconnected from practices. Well, we will revise the current standards and make certain adaptations. The third area is the standards requiring further explanations. We'll focus on addressing issues of vogue language in standard terms and unclear technical content. We hope we could align the standards and establish uniform review criteria so that the certification results can be replicated and can be retested. So altogether now we have 13 topics for the first phase, focusing on key types. And this is mainly to address the challenges facing these key types, especially type certification. And moving forward, we will publish the topics in future phases. And right now we have standards regarding 4754, motor, hydrogen engine, and hydrogen cells. And we welcome you to join our team and to guide us. So one of the 13 topics is chip CTSO, and I'll take the chip CTSO as an example to share with you our progress. So we can see that the demand for chips is increasingly strong in GA industry, low altitude economy, and commercial aircraft sectors. We also see new categories of aircraft, new application scenarios, and the developing civil aviation all demand the domestic chips to be safer and more universally applicable. Well, and also we see extensive transfer and integration of system-level functions into lower-level chips, hence introducing new requirements for review. And previously we didn't have clear standards regarding those lower-level chips, so we need to fill in the gap. We hope with the rise of the review projects and with the rise of domestically made aircraft, we can align the standards. Hence, and this requires the alignment of technical standards, the data format, and the data integrity. And this could allow the reuse of data. But currently, we don't have supporting policies, and that's where we begin. We want to fill in the gap. So right now, actually, there's already some mature products in the US and European markets. So the chip development process in the US and Europe rely heavily on industrial alliance and industrial self-regulation. But for countries without clear standards, evidence gathering pathways, and mature chips, civil aircraft worthiness becomes a significant barrier. So given that, we need to establish, it is crucial to establish civil aviation standards for domestic chips. And we need to, first of all, establish chip approval practices and clarify the chip evidence collection path, as well as the quality of chip development. So in terms of the certification framework, this can be understood from two perspectives. One is the minimum performance standards for CTSO. The second is the CTSO that standardizes all elements of the entire design and production processes, including the auxiliary power unit and integrated modular avionics. And our plan is to extract the common features of the CTSOs. And eventually, we hope to standardize all the elements covering the entire design and production process. And also, we need to complete the functional verification of chips. For this part, we will have independent software review and consolidated hardware review results. So to be more specific, the physical elements of chips can be reviewed independently. The drive engine, the software of chips, will be reviewed together with the project. The physical side are common across all projects, but the softwares and the driving software are different across different projects. So that wouldn't be done together with the project.
In the scope of the chip review and the equipment review, for the chip, we only focus on the chip functionality. The definition with upper layer should be clear in terms of interface and API. The applicants will declare himself that the functions and the feature of the chip. Based on declaration, we'll do the review and process so that the minimal function or performance list requirement can be more integrated with the actual needs in the project. Then in terms of the data sheet, and we will faithfully record based on declaration what are the functions and the performance and the relevant compliance data, so that we can do the chip level review at the device level based on the device manufacturers and the CTSO data source from the chip. They can choose the chip product and also the DAL level, and functions, performance, etc. For the chip reviewed and with the devices, the compliance data after has been reviewed at the chip level, so that our practice can ensure that the systemic devices can be aligned with the chip functionality. On this slide are some new requirements based on the existing OEM, the systems, subsystems, and software and hardware review, and we have the underlying chip review requirement. Based on the chip review requirement is based on the traditional methods and standards. It is extension, and there are some like new verification based on the emerging needs. In this process, for the chip review, it mainly involves two parts of requirements. The first one is the verification of needs. Secondly, based on the physical entity, the physical object of the chip, we need to complete the process control and also components management for the chips. We need to record all kinds of work that is required for the underlying layer and conclusions. In the front end, we need to join with the devices through the needs, and we capture the version of needs. Based on the interface, we may have the clear front-end transmission and the confirmation. On the back end, the transmission is mainly based on the report and also the message. For the chip level, analysis cannot complete all kinds of functions and features, so that the extent of the review for the functions is based on a report, and we record information in the report. We get the data, and we can reuse the data for building a bridge between the devices and the chips. In some of the projects of us, focusing on the domestic chips, and we already started the review process and approval process. And in this approval process, and we recognize some key issues. The first issue is that for the general chips, the transmission of needs requirement is different from the traditional model. Normally, the V-shaped model means that in the beforehand, we need to get the needs and also the capture the requirements, but the chip itself is universal. Therefore, it faces multiple users. In that case, in the front end of the project, in terms of requirement acquisition and the verification, that can be different from traditional V-shaped model. The confirmation only in the process of selection, the final stage of the users, then we get confirmation of the needs instead of beforehand, so that the V-shaped model can be different from the general or universal chips, and the data generated can be different. Secondly, in the process of review for the chips, and we may find that the commercial, the COTS IP protection, there is some mentioning of this standard in the regulators, but traditionally the classification is based on the COTS IP from the OEM and the third-party authorization. But in the process of reviewing the chip based on the OEM, some of the COTS IP cannot be clearly defined by the OEM. It is not defined in the traditional regulations. Therefore, we need to go back to its safety core or essence. The COTS IP in the whole system, it is like the black box. Inside the box, in a white box, and we can accept the certain extent, the existence of certain black boxes. But as long as we need to ensure the inner errors will not penetrate or to impact the system level actions and to ensure the COTS IP stability, then we can agree that we may have some certain black boxes in the larger white box. We may get the firewall design and also the construction, the structure management, etc. By all these methods, we can accept the existence of regional or the local black boxes. In the process of chip review, we also found that for the chip manufacturing and production process, compared with the 254, the traditional electronics manufacturing process is different, because for chip, for itself, usually the applicants are from the design institutes for the tape out and for the testing, packaging, or the outsourced. Therefore, they cannot support us to complete, just like traditional, the 254 requirement, all the subjects, all the objects. Therefore, we accept the general, the batch testing method in the chip industry to ensure the quality control. That is the same process we accepted objectives and in the 254, and we made some modifications based on the chip, the nature of chip. Fourthly, in the review of the chips, traditionally, for the electronic components need to meet the ECMP and 6239 requirements. And there are 8 aspects of data protection requirement, but they mainly focus on the device level. Therefore, as a chip company, not all the data can be generated and stored. Therefore, recognize some of the requirements that should be generated or fulfilled by chip companies based on the required format and deliver the information to the device manufacturer. So in the compliance process, the manufacturer for the devices can get the data from OEM. Fifth, now the products will say need to take care of the large aircraft and also the low altitude aircrafts. For different types of aircrafts and their scenarios and features can differ greatly. So how can we use a unified standard to regulate all the chip testing and also verification? That is a major issue we're facing. Traditionally, and in the industry, there are automotive level and also the military level and aerospace level, some of the standards for testing and verification. Now, for different products type, they may choose different standards. For us, if we hope to use only one unified standard for regulation, the result is that we may give some companies a hard time. Therefore, for the chip manufacturers, they have the self-declaration about the testing method they adopted, no matter automotive or the military or other types of standards for testing. So the applicants declare themselves, and based on declaration from the applicants in the whole review process, we may implement the review work. Then for the testing verification result and some of the proof in the data sheet can be mocked. Namely, the verification standards were accepted and the methods. And finally, the upper layer, namely the device manufacturers, will choose themselves acceptable standards and implement the work, the upper layer design. For instance, I may use automotive standards, and some of the costs can be controlled better, but we are a higher security level product. In that circumstances, we also need to set up some structural alleviation methods by device level structural measures based on the cost acceptance. We can ensure the safety of the product. For the chip review process and the complex system review process, that is also kind of connected to meet the data reuse and data compliance requirement. In conclusion, for CTSO standard and review and considerations, there are 3 types. We need to classify for device manufacturers. They may choose themselves and the compatible standards so that they can lower the R&D costs and to improve competitiveness. At the same time, they can get all the ECMP data required by the device manufacturers. At the same time, we can have the segregation of duty of the functionality between the chips and devices. In the past, the channel, by the questionnaire, the report, and to the chip manufacturers, we can have the records and the communication channel between the chip and the devices. For the chip manufacturers, and we clarify the airworthiness requirement for chips to expand the scenarios for aviation, to lower the pressure for multiple level and repetitive review. In terms of design, we regulate the process and the design activities and also data records so that we can make the requirement more explicit for design activity. We clarify the interfaces, functionalities, and the open issue report and to segregate the duties. For the airworthiness review based on the high security requirement for the aviation, we clarify the design activity for the chips. For verification, we give the industries more flexibility of choices to promote the healthy and orderly development. At the same time, we can ensure the chip security for the civil aviation to ensure the unification of multiple layers of review. Above is my report. Thank you.
Thank you very much for this presentation, giving us an overview of testing. And our next presenter, although he is Chinese, he's coming from abroad because he's working abroad in the University of Cranfield. So you really see we jumping around the world. And he's also working in testing and verifying methods, so a lot on the software side. And it's very interesting. We talked a bit already in the days before, especially the data and security development on eVTOL as his key subject. So I'm sure you will like the presentation and see what is going around the world. And that's, again, the reason for the forum. So welcome, Liu Linghai, and let us know what you do in UK.
To start with, I want to thank the host to invite me to this meeting and this forum. Thank you again for listening to my speech. The topic of my speech is about the airworthiness certification based on the simulation process. 3 parts of my speech. Because it's my first time attendance, I want to spend 2 minutes for introduction. Second and the third agenda is about, in the past 7 years, it's about the Yasa and Leonardo. We joined them together about a helicopter airworthiness certification for based on simulation. The third part is Yasa, Lilia, and a Volocopter. We joined them together for eVTOL, the airworthiness guidance based on simulation. My CV, I now mainly have the research on the fixed wing. The fundings from the Rolls-Royce and some of the EU mega projects. And we got the ATI funding from the UK Vertical Aerospace, help them to manufacture the third generation blade. And this year, I won the presidency, a President Award for in Venice and in the 51st Euro Rotary Conference. I won the President Award. In terms of my research in eVTOL, started from 2010. When I was a postdoctoral program, I joined in the EU MyCopter project on eVTOL research. I joined with Philip, my colleague, and we had the careful research about the handling quality and also the training method for eVTOL. Please refer to my paper for more details. Currently, for the mainstream OEMs in eVTOL, the response method model, we can see some contribution from my project. There is a high recognition from industry on this project, but it is a regret that we did it too early, earlier than the opportunity window. Mark Moore in 2014 contacted us when he was working in NASA on this project.
Also done some research in helicopters, mainly with Altero in Canada, National Council. This is based on the so-called super slide structure. I've also got nearly 15,000 hours of real-time modeling and simulation experience. I worked with pilots, with 30 pilots with different backgrounds. This is my own lab called Railsless Future System Lab. So I mainly work with US and UK organizations, focusing on modeling and simulation. And we've got nearly 20 years of collaboration experience. This is Chief Test Pilot vertical aerospace. In September, their flight test team and airworthiness certification teams all joined us, and this is the picture taken with Leonardo and other pilots. So the second part about airworthiness certification based on simulation. In the last few years, EASA, FAA, and many big companies have invested heavily in this area. However, this is not a completely new area. EASA and FAA, in their documents, clearly support the simulation test for airworthiness certification. And they also mentioned those keywords, calculations, equal in accuracy. So in the last few years, those key organizations have published simple guidelines, including NASA 014 and NASA 7009. In automated vehicle certification, they have also published lots of important documents. Also in the industrial nuclear sector, they also did quite a lot of simulation tests because they wouldn't be able to do real-life tests. So they have gathered lots of methodologies and data around simulation. So nuclear sector is also an important sector to look to. For instance, Boeing in 2018 did an important report. For new type, they would increase the simulation application percentage in airworthiness certification from 10 to 35%, and for a derivative model from 35 to 70%. And Leonardo also followed the same goal. In the next 10 years, they would use the simulation to do airworthiness certification, and they are also at least 50% of that would be based on simulation. And they also used the same method to do AW169 to assess the tail rotor loss of effectiveness. So as you can see, there are lots of benefits to simulation for airworthiness certification, and I could summarize those into 5 points. So first is low risk, especially if you want to do one engine off or reject the takeoff or rotor rotation or failing aircraft control system. Also, controllability and maneuverability is difficult to achieve in real time. The wind speed needs to be 0 to 17 knots, but this can all be achieved in simulation. That is repeatability demonstration, and the fifth is it is supplemental to previous experience, and based on such experience and data, we could speed up the white type airworthiness certification. Let's look at an example. So this is the possible test points of dynamic stability in the DOP. Well, technically, 10,000 points needs to be tested. However, based on our method, 63% of the test points can be covered by simulation. Second, we could have different levels, and I'm talking about full credit. That means 100% replacement or substitution. In 2019, EASA and Leonardo and DOR FOR and our team won the Clean Sky Tool project. And together we developed the simulation guideline. This project was launched in 2019. In 2023, it was first launched, and EASA and Leonardo pilots, they also joined this program. So it's quite a complicated process, and the whole picture demonstration took 3 hours when we first presented it, so I won't dwell on the details today. Based on these guidelines, we did 4 case studies to help people understand and implement this guideline. 1, 2, 3 are based on Leonardo Helicopter 109. It should be done on 189, but 189 is quite new. Leonardo is a bit reluctant to share the latest data, so instead we got all the data from 109. The fourth is around tube rotor, but the data hasn't been published yet due to confidentiality. And I led the third one, dynamic stability. 4 months ago, we released this guideline. You're welcome to download this document. It's all free. And in the last 4 months, 23,000 downloads. Helicopter is a rather small niche area, so 24 times of download is quite impressive. So the industry is very interested in this guideline. And we see this guideline has already been applied in Europe by several key players. So this is the motion tuning. Is a common pain point, and there's lots of areas to further explore. This is the same trials for demonstrating dynamic stability. I spent almost 12 months to prepare this test, and I redesigned the maneuver. You could see EV295, and there it clearly states the differences between eVTOL simulation and the traditional simulation. And certain adaptations and revisions need to be done based on the specifics of the aircraft. For the third part, I want to talk about what I've done in the last 4 years in the area of eVTOL airworthiness certification. Personally, I believe we are now in urgent need of simulation-based airworthiness certification. These are my 8 reasons. You could look at number 4. eVTOL is not a new thing. When I was in Germany, a small town, most of the types actually were already there and were already studied during the Second World time. However, in terms of control and many other areas, we still need to do more work. My director in 2019 also talked about this. In lots of OEM design, it also followed this principle. eVTOL propeller and tube rotor also have those special phases. For instance, conversion corridor is highly unstable and highly aerodynamic related. All of those are coupled, so that together pose great challenges to airworthiness certification. Also, OEM, they don't feel assured doing real-time tests, given those risks. So how to solve this problem? Lots of those eVTOL companies, they only have enough cash to run 9 months to 12 months. So they are in urgent need to convert their types into market products. So how to speed up this process? Well, I believe simulation-based airworthiness certification is the best solution. So what's EASA's and FAA's attitude towards this simulation method? Well, you could look at their guidelines, and both of them recommend simulation as long as safety can be assured. However, the specific implementation paths are different. EASA is process-driven. EASA takes a process-driven organization, process-controlled philosophy, and they need to be certain about every process. And only with that certainty, they would be willing to credit you. But FAA takes a applicant-driven process. And the applicant need to give data and a verified model. They also ask you to provide safety-related cases. This is the EASA's special condition-related information, and many of those relate to the quality of operation. And on the right, you can see the latest table. In September, EASA's friends given us a special report. So operation quality has been closely related to eVTOL's document, atmospheric disturbance, a flight envelope, and other flight conditions are specifically mentioned. This was done 3 years ago. This is the design guideline for military helicopter ADS-33 and VFR CS2927. All in the same picture. EASA is quite interested in this picture. So eVTOL also have the same problem. What is the operation quality standard? And what kind of operation quality standard would be aligned with the airworthiness certification, and how to revise the ADS-33 boundaries? All of those boundary figures are based on thousands of hours of flying experience by military pilots. Those boundaries need to be revised. It cannot be applied directly. How to revise that? Different OEMs have different approaches and standards, and this requires lots of experience and data support. 3 years ago, we realized the importance of operation quality. EASA Lilian led a team, WG112, and established an industry-wide airworthiness certification guideline. Helicopter is now the new leader, and the draft has already been developed. This month, EASA is reviewing it.
1 month later, or in January, it will be published. I'm one of the writers for this new draft. So any questions about handling quality, about the certification, please write email to me and for questions. For the US, they're doing the similar thing for SEG-35, SAEG-35 into A, B, C, and B is based on simulator. There is a new fidelity level requirement for the next level, next generation simulator fidelity requirement. There is no classification between the fixed wing and helicopter. It is a unified standard, but dynamic platform changes are obvious, so we need to pay attention to it. The draft has been announced. The formal release will be in September next year. The G35C is based on modeling and simulation. It's mainly for the fixed wing. In February, the guidance was also issued. It's the 094 guideline for Eurocard. it is not independent because many members they have the overlapping membership in different organizations. So for each month, we have some communications with each other. I've mentioned about the benefits of simulation. Of course, it is full of challenges. I summarize the challenges as the following 10, summarized into 3 parts. The first one is funding. Second part, expertise. Third is about manpower. I've been in the industry for 7 years. I feel that it is a multidisciplinary industry. The requirement for personnel is not only mediocre. Instead, we require some people with more than 15 years of research history in certain areas, for instance, the aerodynamic and how to build the high definition, high accuracy model and simulation environment, and how to adjust the dynamic simulators, and how to have the flight test meeting the compliance requirement, how to communicate with the pilots, how to interpret the current special conditions provisions or some of the new provisions from the ICAO certification and reflect them into the simulation environment. That is a test for money, expertise, and manpower. The current OEM, only 100-200 people are dedicated to this part of work. That is not sufficient. Therefore, we're still facing challenges in CBS. For large company, for instance, the auto flight, some 700 people participate in this endeavor. For Judy, 1,600 people. Xiaopeng, 1,200 people. And I think they're capable of doing this part of work. Finally, I want to end my speech with one sentence. We just need to view the simulation as the deliverables that can be certified, not only a pure tool. About this, my speech. Thank you.
Hello, you. Please stay here. All the speakers from these sessions, we will get chairs on the, and we will have some, and I really try to get everything in time. So we are in time. We have half an hour for questions. That's why we try to get the speakers from around the world here, that you can ask also questions. So we will have microphones bringing you to you so that you can ask the questions. And if somebody of you also have another answer on a question, he's welcome to raise his hand, because I know all the audience here are very competent people in this field of eVTOL, which are working there for a long time. So, so Scott, Emmanuel, you, and who else? You maybe you have a mic? Yeah. Maybe I give you the mic and I stay here at the. Some more mics. Have a seat, Emmanuel. Yeah, Professor. So maybe you can. Yeah, please.
现在是这个是一个讨论时间，大家有任何
Now it's time for discussion. We can propose questions to the presenters.
You don't need a translator, Liu. That's good. I need one for sure. I have to set it to the right language, which is. So, if anybody has a question, just raise your hand. If not, I would start with the first question I have right now. So, seeing how many things has to be done for getting this kind of aviation flying. First, perhaps the last speaker, Professor Liu, would you say the existing infrastructure of having SC-VTOL and FAA and CAAC
is already enough harmonized, or do you think what are the most important points where we have to get more harmonization to get global electric? Because we have eVTOLs flying in US, eVTOLs flying in China, only very few now flying in Europe. What is the key point where we have to get more harmonization?
Okay, can you hear me? Yeah. Okay. 就是那个
I myself didn't participate in the harmonization of standards. So I think your question is about the FAA, EASA, the airworthiness standards. There are some discrepancies. So for OEMs, no matter in the UK or the US, they need to have the market to avoid some repetitive compliance testing. And what should we do? I have a friend in EASA who is responsible for the compliance. Each 3 months, he comes to the US. I ask him some questions. EASA FAA has done a lot of work in this part, harmonization. For instance, EASA and FAA, between the two parts, they are trying to converge instead of differ. Last December, they had a major breakthrough. As far as I know, they are now taking some concrete timesheet to take measures. But the thorough harmonization or to replace each other, it is still a long-term project.
Yes. No, thank you. And yeah, because when I was talking, especially with Chinese here and with Europeans before the travel, there is really the question that, like Emmanuel described, EASA is working on a safety system. I know in China they're working also on a safety system, but there has to be standards. For example, if we talk about safety in operations, there must be some communications of the vehicle to vehicle, vehicle to ground stations, and this must be a kind of communication which is not voice, because voice, like a drone, an unmanned drone, that normally doesn't have a voice. So maybe, Emmanuel, you can ask something if you are aware of some more harmonization standards, because right now, okay, if everybody already knows who are the others, it's a big achievement, like you explained. But for the future, there should be also like, and this will be the second question to you, because there must be some modeling as well for how this could operate. Just to know where they are at the moment is one thing, but to know how they will be operate, how they will react, I think this is a difficult thing as more people you get into the airspace.
You're absolutely right, Willi. We're living in a time where technology is evolving extremely rapidly, and where the various countries start to understand that aviation, it's one nation, and it's not because you have a physical border that the planes will start to fly differently, or that the air molecules are going to behave differently. So what we're seeing between the FAA, EASA, CAC, Transport Canada, what we're seeing is that more and more they understand that it's time to simplify and to have a common understanding across borders. It's also a time where the technology of our aircrafts are evolving very rapidly. And if somebody had told me 10 years ago that I would witness the moment where a manned aircraft could suddenly transform itself into an unmanned aircraft, and you go like, what is he talking about? Well, if you look what Garmin has done with the Autoland system, basically you have a pilot flying a Cirrus jet, a Daher, TBM, plane like that. Suddenly he is incapacitated, cannot fly anymore, and any passenger in the aircraft can push one button, and suddenly the plane takes over and is going to interrogate its database to see where is the closest airport with a runway that is long enough. Make sure that the wind is going to choose the runway because the wind will be favorable for this runway. It's going to fly with the autopilot the plane down. It's going to call ATC with a synthetic voice and saying, Mayday, Mayday, emergency landing at that airport. It's going to advise ATC. It's going to go 7700 on the transponder. It's going to do everything a pilot could do. It's going to land the airplane, stop the engines when the airplane is safely on the runway. So effectively, a manned aircraft suddenly became an unmanned aircraft for the better of safety. That happened in 3 years. From the first moments we heard about that system until it was certified, it only took 3 years. But if we think about it, imagine the reaction of the people working at the FAA, at EASA, when the guys from Garmin came in the first time and said, look, we've got a cool new system, you're going to love it, and we need to certify it fast. A few years ago, it wouldn't have been possible. It would have taken 10 years. And there, everybody immediately understood the benefit for safety and said, we need to railroad that thing. We need to fast track that thing. So things are changing a lot, and I think for the better. And technology is helping, but the most important thing is that the people in the administrations understand the necessity to accelerate the arrival of technology when it benefits safety. Well, at least that's my humble opinion.
Okay. It's interesting because you talk about this achievement, and you're totally right, in the certified world of aviation, but I, as a guy who is always complaining, as you know me, I think, yes, but this is a system which costs €500,000 for a certified aircraft, and we will have much more aircraft there. And so it has to go even farther, and it has to go into smaller dimensions so that we will have other systems implemented, because if it's a €500,000 system, you cannot afford to put it to an LSA, which is costing €1,000 or €100,000. So I hope, my hope is actually that for the whole of the world and for getting more data, also for accumulating data for simulation, that maybe MOSAIC can also influence other countries to getting similar standards in the world below the certified aircraft. And there I have a question to Mr. Xu Shang, sorry for pronouncing your name wrong, because we know for quite a while the former director of CAAC certification. Do you think that the LSA system in China could be also modified in the way that FAA is working on MOSAIC now, so to get a larger scope of LSA aircraft, eVTOL in the LSA class, which are not for professional transport, but which are made for other operations, for example, flight training, and having this in the CAAC scope?
That's a very interesting question. For CAC, it's also an important question. Simulation-based review. Well, right now we already have certain documents indicating the applicability of simulation data. But that is based on the scale of the data and the accuracy of those models. And this should be based on sufficient amount of data and experience and models. CAAC has done quite a lot of research analysis, and not just us, the entire industry has done quite a lot. Liu Xiaojie, Deputy Director of the Certification Center, is also here, and you're welcome to add. International cooperation, be it bilateral or multilateral, be it communication with EASA or FAA, have all talked about these issues. So eVTOL is a relatively new aircraft, and we are still at an initial stage. eVTOL is a new thing. After all, countries around the world and authorities around the world are still gathering data. So simulation is definitely a trend. It is more economic and cost-effective, cost-efficient. It also is not as high risk. For instance, right now in China, we have lots of electric cars, and all of them are connected via a so-called smart network. But that's only possible with the support of sea of data. That is necessary, and I believe in the next 5 years, we will continue to see simulation being the future direction. So for CAC, FAA, EASA, this is a new challenge and a new task. We will see more exchanges, but right now we are still collecting our data. We're still in this phase. And we will carry out different types of research and have different research directions based on the status quo of each specific country. I understand that you hope to get standard alignment and harmonization so as to reduce the burden of applicants and increase the efficiency. But still, I believe right now we are still in the phase of model building, data collection, and experience gathering. Definitely, it's necessary for different authorities to establish a working mechanism or perhaps a working group under a civil aviation organization. And this may be more beneficial for us to have that harmonization, because aviation knows no borders and no country could address this challenge alone. eVTOL, UAV are no exception. It's also an international industry. So establishing uniform standards, establishing uniform models are conducive to the development of the whole industry. Xiaojie, anything to add? FAA, EASA, CAC, well, the harmonization of standards is our pursuit, as mentioned by Director Xu and Mr. Tao earlier on. Alignment and shared development are critical. Well, Professor, you based in the UK. The UK's left the EU, so the UK now has a rather sensitive relations with EASA. What Mr. Xu just mentioned is quite constructive. And the promulgation of international policies still need to rely on the pilot implementations under the international organization, and different countries they all have the right to make recommendations. I noticed that you've given us the iceberg picture, and it's quite clear. It addresses this topic from perspectives of cost saving, risk control, and safety. Well, in terms of path development, first of all, we need to align with the international civil aviation organization, and on the industry level, government institutes, research institutes, and academic institutions could form an alliance, develop a draft. And then start from there. Actually, all countries follow the same route. EASA, Chinese government, their policies initially are all based on those academic and industry frameworks. Earlier, and the fast track may still require 3 months. If I remember correctly, that was mentioned by a previous speaker. Though different countries have different legal processes and procedures, but the basic logic are the same, and we can follow the same route to seek common prosperity. Thank you very much, four gentlemen, for being here and to share with you your thoughts on airworthiness certification. I'm quite inspired. I used to work in CAAC, responsible for civil aviation rules and regulations. We've got good cooperation with FAA and EASA. In recent years, due to some geopolitical issues, our collaboration to some degree impacted. But now you are here. I hope you could share with us more insights on the technical development of eVTOL, the impact of eVTOL, and how it could play a bigger role and be safer, be more convenient, and be more cost efficient. I hope you could go beyond the geopolitical constraints and make your contribution when you talk to the government. And I believe that's the value of experts.
The idea overcome the political constraints, I think we as aviators, we think very similar what should happen for aviation. I have a question for Scott, and don't forget, if somebody of you has a question, raise your hand and we can put the question in. I have a question for Lama. As you have members from all over the world, do you already have, after MOSAIC was finally released, requests from other countries who say, okay, we're going to take on MOSAIC as well, especially with the focus on eVTOLs?
At this point, thank you, Willie. At this point, we don't have that aggressive questions yet. Part of the reason why I am here is to promote that, because I think as we have been a strong influence in the United States, we can be around the world. As well as you know, we travel to Aero Friedrichshafen in Germany, and we'll be down at Aero Asia at the end of the week. And all of this is to support that international cooperation, and everyone, when we work together, we can do things more efficiently and have more success. And to that, success breeds success. So as each country is successful, we should have that synergy and develop that success worldwide.
I have an additional question. As we had, or we have two people who really know about the CAC policy here in the room. A quick answer, can you, because when LSA was released in the United States, CAAC and EASA both converted this non-certified class into a certified class. So there is a EASA SC LSA certification and there is a CAAC certification. Do you think CAAC can imagine also a kind of non-certified class and even having eVTOL in this non-certified class? Because I think this is a change of paradigm when MOSAIC came on, or when LSA came on, to have a self-declarative certification of aircraft with flying more than ultralight, like it's 2 or more persons. Could you imagine this? So it would be great to get a comment from CAC.
那个，我们看看，咱们民航局的那个钱先生，要不你回了？那个我们还有一位是那个民航审定中心的。
We also got someone from the certification center. Perhaps you could answer the question.
Thank you. Very important.
那个这MOSAIC
So after the release of MOSAIC, Guangzhou certification centers follow the development of MOSAIC very closely. CAAC has a motor aircraft added into this certification category, like what FAA did. And I'm particularly interested in the ASTM standards, especially after the introduction of MOSAIC, as mentioned by previous speaker. April next year and July next year would be two important time points. And the supporting documents of those ASTM must be set up by them. For CAC, we will also complete the certification process for motor aircraft. We have developed our own specific rules and conditions. In terms of LSA, within our department, we have some of our own considerations and plans. A question to Mr. Scott. FAA introduced MOSAIC. What's the intent of that, and what's the effect of that? What's the purpose, and how's the effect? Also, we need to establish some ASTM standards to support that. So, motors and eVTOL standards, we are working on those right now.
Maybe because the translation was a little bit interrupted, maybe now if you could repeat a little bit the question to Scott, because it was not really clear. So maybe you could translate into English, because
Okay, sorry. The first question is that what is the purpose of FAA to promote the MOSAIC, and how is the effect? What is the progress of MOSAIC? What are the considerations behind the promotion of MOSAIC? That is the first question. Second question about the multi-rotor and also the eVTOL. Have we initiated ASTM standards for multi-rotor and eVTOL? Do you have standards?
Yes, thank you very much. The motivation behind the MOSAIC is to revitalize general aviation, which has been declining, not only in the United States, but I believe worldwide. to make aviation more simple and more cost-effective. Part of the MOSAIC revitalization program is to create a structure where the aircraft can be self-declarative certified, which is much more streamlined and much more nimble than the typical Part 23 certification. So the thought is by reducing the cost of compliance with the standards, that it will grow the flying and the aircraft fleet. Right off already this year, as a result of MOSAIC, the Sport Pilot Airman has been able to fly many more aircraft because they have been reclassed as a light sport aircraft. It opened up probably 60 to 70% of the entire flying aircraft fleet in the United States to sport pilots. So before August, it was sometimes hard to find a light sport aircraft to fly where a sport pilot could get flight training because this is a new, very specific type of aircraft, and you can't just go to any airport to find a light sport aircraft to fly. And then after August 22nd, I believe it was, all of a sudden, just about every airport that had a flight training program had light sport aircraft because of the increased definition. So this right off in that short month and a half expanded the flight capability of sport pilot multifold, because now every airport had light sport aircraft, every flight school. So already that is working and expanding and revitalizing general aviation, which was one of the goals. The other is to increase safety, which will be done through the MOSAIC standards, because industry creates the standards. And with that, I'd like to humbly invite CAAC and any of the manufacturers to join the ASTM, because at the ASTM, we are creating the standards for compliance. This goes right into the new eVTOL, as those standards have yet to be completely written. So if you want to create the industry in harmony, where we can work globally under the same standard, then right now, one can become involved with the ASTM and create that standard. So the idea is you could, if you have a specific interest or a situation that is effective in China or in Germany or in any other area, you can participate on the ASTM and modify or suggest the standards so that it is appropriate and not burdensome to your country.
So the clear answer on the question, are there the standards for eVTOL rotorcraft? They are in process of creation, correct?
Yes, they are in process now. And unfortunately, I don't have the details of where they are, but they are in process.
Okay, we get you all signed up for ASTM.
Okay.
One, I think,
maybe give some question for the
okay. Yes.
后边有什么问题吗？咱们后边的那个。
Any question from the audience?
Just a short reminder. Right after this, we all go out to do the annual photo of everybody. So as soon as we finish here, we all go out to do a photo shoot. Okay, thank you.
那个我这不好意思啊，我这个问题呢给那个李先生的，我是搞飞行事业出身，我的主业是搞飞行事业。麻烦你概述一下飞行事业验证软件必证性的证明必证性的方法论，概述一下。这是第一个问题。第二个问题就是说，因为飞行事业很多涉及到试飞员的主观评估，那么如何来这个模拟仿真飞行员的主观评估的一个观点？谢谢。
It's a question to the professor.
Maybe you okay. So maybe you could repeat the question because we didn't have translation of this.
职权快，钱老师是问我吗？
啊，对。
OK， 就是你能重复一下第一个问题吗？哎，对，我会说中国话的。
Yeah, now we'll repeat the questions, the two questions. I'm in the background of the flight test. And you had the sharing about simulation software for the flight test. It's not a simulation software, it's a simulation environment, it's a process, just one correction. Software is only one part of it. Okay, so going back to the software, the simulation environment, could you share with us, firstly, about the simulation environment, the proof methodology? How to prove the anti-vibration or anti-oscillation kind of features? That is the first question. Second question is that the testing requires the evaluation subjectively from the testing personnel, but for simulation, for instance, do the pilot requires special flight skills, and how to simulate the subjective experience of the pilots. The two questions. The first question is how to ensure the accuracy of the simulation environment. That's my understanding of your question. There are several layers. I myself I haven't found the good method yet, so I want to share with you in the past 20 years and what work I have done. So we can test the accuracy of the simulation environment based on my experience. The first one is objectively. There are some objectives and we want to realize. Objectively, there is the perceived fidelity and predictive fidelity. For the predictive fidelity, it is based on FSTD, namely in the simulator, there is the fidelity requirement. That is based on the prediction data, flight data. There is the compliance requirement. For instance, the angle of attack, 30 degrees, and what is the rate, etc. So that is the first part about the prediction of fidelity on the model. We have done a lot of research on that. Even if you are compliant with FSTD, the fidelity tolerance, the boundary. There was one colleague in chip, Mr. Ho. I resonate with one slide of him. In the slide, there is a mega system, which is the aeroplane is like a mega system. From a modeling perspective, what we're doing is a pyramid shape workflow. In the underlying layer is a flight control, aerodynamics. Between different layers, we need to get to the consistency with a real flight environment. Going upper layers, for instance, to the helicopters, there is a horizontal stability and also vertical stabilizer. In the process of modeling, there are some structured data and also the aerodynamic data, etc. And we need to connect different parts to the tail of the airplane. Then the tail can be integrated in with the fuselage, with other parts of the airplane. That is about credibility analysis. Fidelity is one part. Accuracy is not all the picture. The challenge is that how to have a credibility between the modeling and the fidelity for the airworthiness certification. I think for the regulators, you are more interested in the system, integrated system. Then all the parts of the airplane, you can see the fidelity rate, a quantitative method, namely credibility, and also the source of data. In that part, we don't have a good method yet in the world because it involves some uncertainty research. That is the point, the part I'm studying right now. There are two parts, and the first part is a known the unknown. Second is not know what you are unknown of. Because for the fidelity, it is under one condition of flight. There is one credibility. But for simulation testing, it is from the known flight condition expanding to the extrapolate to another flight condition. Then it involves a lot of the unknown conditions and that you are not aware of. How to do fidelity in that part, that is one major challenge in the world and also the highlight of research. About the pilot handling quality and the workload evaluation. I myself was in research for more than 20 years, not only helicopter and the Rolls-Royce project. They put the pilot into the cockpit to complete a task. I have a chart I just played during my presentation to evaluate handling quality. Professor, please find another time for details with the audience. Thank you.
Enthusiastic. We really see how enthusiastic you are on your work, but we have to finish here because otherwise you have to eat very fast, which is not good for your health. So we want to leave you some time for lunch. And I think we go to the photo right now, correct? Yeah. So let's all go out to take an annual photo, then lunch. And 1 o'clock, please be back here in time because we have a full schedule for the whole afternoon and evening. So thank you.
Hello again. Session on eVTOL will start soon. We have just solving a little technical issue. And as soon as this is okay, we're going to start. eVTOL, like you all know, is something which is the hot topic over the last, let's say, 10 years. And with a low altitude economy here in China, we are getting closer and closer to having some regular traffic. And yesterday, here in Kunshan, we could see something which we haven't seen ever anywhere in the world, having, let's say, 10 full-size ton-class eVTOL stationed and 3 or 4 flying at the same time, one taking off a boat. I think, or I know that nothing like this has happened anywhere in the world before. And so I think there is really now a race going on who will be the first with real traffic and passenger transport. And give me a hand sign when you're ready. No, they're still working on the techniques. So that's technology. The great thing is what we have now here is, so I don't have to tell too much, especially here in China, about our next speaker, who is the first speaker of the eVTOL session. And for everybody who's been here yesterday, he has seen what he has achieved already. My friend Tian Yu, we know I was flying his first electric aircraft in 2009. And this actually gave me the idea to create the forum first in Europe and then the forum here. So welcome, Tian, and let us know your latest and what's coming next.
大家下午好。
Good afternoon.
第9年了。
It's the 9th year already. How time flies. Let's play a video first. But that is what has happened in 2025.
最开始的就是我们在重庆。
In the beginning in Chongqing, CCTV Spring Festival Gala, we participated in the performance.
我们也取得了夜航和这个。
We also got the e-航capacity.
我们的物流板也。
For the logistic panel, we did a lot of plans and the extension of the functions. Yesterday, we demonstrated about the parachuting of the first aid materials. We can also deliver the life-saving boat, the inflatable boat on the water.
这个主要的目标跟方案就是消防。
The main target is about the fire protection and emergency. That is for the logistics panel. In July, in Wuhan city, in one festival, we had the delivery of the parachuting of the life float. One, the life float can accommodate like 10 passengers. Therefore, we're able to give first aid to 20 people if they fall into the water.
然后7月下旬我们。
In the second half of July, from Shenzhen, we took a flight to Haiyou, the drilling platform, a total range of 150 kilometers. For the CNOC, the rigging platform, that is one good scenario for application. That is also the need response and for the materials. We made such an attempt. After 150 kilometers, the remaining electricity is some 40%. Therefore, it is sufficient for the whole journey. We transported the fruits, medicines, and tools. Another case in Pingtan for the wind resistance test. Now the wind resistance is some 16 meters per second. Another case in Anhui province, from Hualien to Hefei, voyage transporting blueberry juice and the SF Express parcels. Total journey was 160 kilometers. That is the first inland eVTOL journey as long as 160 kilometers.
这是我们昨天的科技日。
This is yesterday, the Tech Day.
发布了海空议题方案。
We launched the equity proposal.
2000做编队飞行，有一架。
Also, we did a fleet flight show together with other two partners. We departed from a vehicle, and later on, I will talk more about this proposal.
This
is a electric-powered boat. We call it zero-carbon water airport. This is how it looks like. That's the first prototype. We've got lots of data and did lots of analysis. This is its interaction with the aircraft. It has solar power and solar power storage facility. Can use solar panels to generate and store electricity. The energy stored can be used to drive the ship and charge eVTOL.
We
have the bigger volume. All of these are still testing, and the purpose of this project is to further expand our application scenarios, for instance, to more water-based scenarios. And next, I'd like to talk about another case example. Land-sea-sky integration proposal. Okay, now let's move back to the presentation. So earlier, we just saw the video of the solution we published yesterday, and it has several application scenarios. All of these are based on the zero-carbon water airport, and we have solar panels and power generation facilities, as well as they can takeoff and landing pad and the charging area. Within the cabin, we have the waiting area and OG zone. You wouldn't need to have the range extension for a journey within 100 kilometers, and if necessary, you can have. We do have two range extension facilities. These are typical applications. One is energy operation and maintenance, for instance, wind power and CNOOC drilling platform. We can have a zero carbon water airport, as I've mentioned, for cargo transportation or maintenance and services. A second application scenario is high frequency commuting. We can park the boat at the pond and form a mobile port. So we can transport passengers from downtown area to Hongqiao, to Pudong, or to Suzhou, because our range is about 200 kilometers, so it would only take 10 minutes traveling from Hongqiao to Pudong, saving lots of time. The third application scenario is sea sky culture tourism. This actually could be applied in a wider areas, not just sea, but also lakes and rivers. We could carry out cultural activities there. The fourth is emergency rescue. We have V50, the white shark. Capable of landing on the upper deck of the airport. The lower deck, we could land a larger aircraft. So the upper deck aircraft can be used for search and rescue, as well as material drop-off and personnel evacuation. So it can be a rescue platform. And it also allows mobile response, has more efficient response. And the last one is super node or super hub. We have enough traffic, say in the Bond area or in Hongqiao area, we can form a sea air super hub, forming a cluster. So we could evacuate more people, more traffic. We could also mobilize the takeoff and landing platforms to different locations as needed. That's all from me. Thank you.
Thank you, Mr.
Tian. So each time auto flight surprises us, we are quite impressive by the solution Mr. Tian presented, and we wish you every success. We'd like to invite our next speaker from Aerofugia, Mr. Guo Liang, Chief Scientist from Aerofugia, and he's going to talk about progress and challenges of Aerofugia's passenger carrying eVTOL. Let's welcome Mr. Guo. Hello, everyone. Good afternoon. It's such a pleasure to gather with all of you here. Every year, I come here to report to you our progress. Well, today, last June, we completed the whole size, whole weight test. And since then, we have been working hard on making breakthroughs. And today, I'd like to share with you our progress from the verification of a trial plane to the success of a small-scale eVTOL. We've learned a lot and get lots of experience, and I hope to share our understandings with all of you to speed up the development of the eVTOL industry. Here is the big background. I will probably be brief about this part. I will spend more time on our progress and our thoughts. One thing to note here is that in September, the new government transportation department introduced the IPP program, integrated pilot program, EIPP program, hence allowing test operations before obtaining FAA airworthiness certification. And this is somewhat inspirational and worth research, worth studying about. Next year, when times are mature and conditions are ready, we can also do some pilot trials to gradually enhance understanding of eVTOL. EASA also has its own methodologies and thoughts, as well as the theories. So EASA are the first to propose the design basis and certification foundation for VTOL. They have contributed a lot, including in the design side and operation side. They also set high standards for entrepreneurs. And for early commercializations, this may pose certain challenges, but different countries have different rules. We can also borrow their success experience from EVISA. That's only my personal view. Next, let's move on to FAA. FAA are also gradually adjusting their rules and upgrading their policies. So far, after a whole cycle of development, they now encourage bold innovation and practices. Like China, the US and China will both be large single markets. In 2028, we'll have the Los Angeles Olympics, and they hope they could have large-scale commercial applications before that. So all the policies and all the frameworks would support that full commercialization by 2028. And we can take that as a reference, I believe. The last part is CAAC. We'd like to thank CAAC for their support in the last 2 years. They've given us lots of guidance, and they've helped us a lot. They've given us lots of support to our future and auto flight, as well as many other institutions. So we have actually lots of good conditions. We have good infrastructure. We have supercharging poles. Those poles are quite advantageous for eVTOL. Also, we have 5G and 5GA, and this is very helpful for route control and ICT control. I believe these are the good foundations for developing low-altitude economy in the future. So this is my focus page after a year of development about airworthiness certification. We have learned some new things that we have missed or misunderstood previously, or breakthroughs we made. For instance, in the motor area, our Longfei motor can provide the best energy solution. Also, we have done quite a lot in energy reduction and also the damping of vibration. Also, we have also studied the failure scenarios. And you'd find that actually it's more complicated than the traditional aircraft. Redundancy is helpful, but this also will give you more failure scenarios and more coupling issues. We hope these eVTOL aircrafts could have less requirements to pilots, so auto handling is crucial.
Therefore, for the danger evaluation, safety evaluation for the airplane, including the failure risk, we have done a lot of work. They look like maybe only hundreds of pages of paper, but behind all these written documents, there is a simulation and testing, which is the vast amount of work. As mentioned by the experts in the morning, they are like what is beneath the seawater of the iceberg, including the noise. And I think noise in the future will be the major advantage for e-flight. It is also acceptable for the general public apart from safety, because we need to pay more attention to the third-party participants, the feeling. I'm on the airplane, if I'm in a hurry, I may tolerate higher noise, but for the citizen in the city, in their daily life, they should not be impacted by the high noise from the eVTOL. That is important. For Joby Archer, in terms of noise reduction, they have done a lot of work. We need to choose a low rotating speed. Apart from the design requirement, noise reduction is one important reason. So today we can just share more experience and lessons learned in the past. So I think in the future, in the standards making, noise will become one important topic for eVTOL development. Another part is about the power energy system. 3 or 5 years ago, we thought that this part we were confident because China's EVs were good enough, but later we just found the top motor suppliers in China. We found that for the motor for automotive, the industrial standards are not sufficient for the aerospace. For instance, the redundancy design and also the low rotating speed, the power output requirement. For all these parts, the automotive industry is not capable enough. That's why we had the cooperation with Willi, the chemical reaction between the two parts. So for new energy aerospace and the aviation can have some overlapping part with the EVs. For our suppliers and prediction in the future, some 80% of supply chain can be related with EVs because of high overlapping. Some 20% critical devices should only come from the supply chain of aviation. Critical minority, 80% of overlapping part. Despite of the high figure, the industrial bases are not high enough for the e-flight. E-flight is like pulling the traditional supply chain to electrification, to new energy-oriented development. At the same time, the e-flight is pulling up the EV supply chain to high safety, high performance, making more breakthroughs. Compared with EVs, the margin and the value can be higher, so that the OEM may have larger room for improving the cost by adopting better materials and technologies to lead the industry. Dozens of years ago, that was a relationship between the EVs and also the aviation. In the new energy era, there is a new magical chemical reaction between the two industries. And about the crash-worthiness design and also the structural arrangement. For instance, a battery for the 4 batteries and how to deploy it and how to dislocate and how to maintain the heat runaway, thermal runaway control, etc., including the floor design. It is different from the fixed wings or from the helicopters. We spend a lot of time in this part based on the eVTOL failure model or the particular the crashing model. So we have some anti-crashing design. That is one interesting point. In the future, if we have more time, I can share with you in terms of academic part the latest progress. I think you are quite familiar with our products. So we have the small mass production products, small batch, already into production in September. I will not dwell on other products. For the new workshops of us, and when you come to Chengdu, by the end of the year, we will complete the construction of the main buildings. Next year Q1 preparation for production, and then we go into the operation. We welcome your visit. I think you're familiar with this type of aircraft. In terms of noise, that is interesting. We already have some authentic data. We are confident that at 300 meters height, the noise at the ground is some 48 dB. That is the equivalent of the silence state in this meeting room. So there is no impact for the citizens in cabin. The noise is some 65 dB, equivalent to the high-speed railway during the traveling without anybody speaking. R&D went through multiple rounds of iteration, and I think for the brand new aircraft, we need to went through this objective and recognition about the unknown. Since 2019, we initiated a project, and then we had 3 rounds of major iterations. Now we selected on the rotor and the low rotating speed. After more than half a year of the testing for this type of aircraft, we are already quite confident. I just came back from the Dubai flight show. I'm very happy to see Joby, the on-site flight performance. In the first day, I was so impressed, so I came to see the performance again the next day. I need to recognize that we are lagging behind to Joby, and we need to learn from it. At the same time, I'm very excited because we're drawing closer to the standards of Joby. From 1 year to 2 years of gap, now it's only several months of gap. After they announced the airplane for TIA, and in the testing period, we nearly synchronized the same progress of TIA. As for in terms of the passenger vehicle for the ICAO standards, for the airworthiness part, and with the leadership of the CAAC, and we try to build up the feasible and the fast involvement model in the industry. In last November, after signing the CP, in the whole year, we were implementing the test flight. Now we are doing the ground test for the product. You may concern about when we can put the aircraft in the sky. Please be patient. Last week, we just had the meeting in CAAC with the leadership of the CAAC. We had evaluation work on the maiden flight, and we are cautiously, with cautious safety standards, and we will implement the manned test flight after this period, and we are going to relatively fast track of development. We hope that we can lay a solid foundation in technology and strength, then we can take off safer and faster for the iron bed and also for all the rig test. We also have the so-called the bronze bed, because for the aircraft there are some high voltage devices. Therefore, we designed the bronze bed test. I think that is some initiative in the whole industry, new testing environment. My colleagues listed for me some of the Joby performance. I would just want to draw some reference. We have done a lot of ground tests. By the end of the year, the aircraft will go through the flight test. That is the airworthiness status based on we signed the 145 airworthiness the labels and agreements, and then we go into the manned flight period. Some of the stories behind, and for instance, the battery, in the beginning we hoped to find the battery supplier, but we had extremely high requirements on thermal runaway. In the end, we could only design our own battery pack. We could ensure that there is no damage during the thermal runaway, there is no dismantling of the battery, and we have the pressure release channel and out of the aircraft. So the whole concept is quite similar to Joby. I want to demonstrate the one on the right.
对，这个视频后边会展示。我以为右边这个是视频，实际上就是右边这样的，在一个当然我们
On the right side, we had the high pressure test for the battery pack when there is a thermal runaway and how much pressure it will generate. And now we can already be confident in the performance of the battery. You may see that for the design of batteries, there are 4 pieces and distributed, so the damage in one battery will not impact the normal operation of the remaining 3. We've done a lot of work to ensure that for the system in the bronze bed testing, the whole system structure is complicated. But all this complication brings about higher safety level. We recently did the lightning strike test based on the safety requirement. We need to consider that for the low altitude, if there is accidental strike by lightning, we need to consider such a risk. So we had the electrostatic protection and lightning protection measures. There are some the experiments in our labs. We have done a lot of work in terms of the wind tunnel. We need to consider the status and during the mode transfer and some of the special circumstances, handling. We still need to rely on the wind tunnel test to close the loop. The majority of the data is from the CFD, but during the slow rotating process and also some aerodynamic issues, we have accumulated a lot of data in the wind tunnel. We didn't have enough time to write a paper. Next year, we'll try to squeeze the time to publish the papers. It is extremely interesting. So for the teachers and professors, you can have more study on that. There is some coupling issue, controlling issue, and incentive issue, etc. For time's sake, I will be faster in my remaining part. I think you're familiar with all of that. Mr. Tian Yu mentioned about integration of the sea and the air. For Sichuan, it's mainly about the tourism and culture. How can we make it easier for you to see the panda in China? And we talked to the Sichuan Airlines. And we have some connection, so in the future, and for the traveling and the routes, and we'll have some coordination and in doing demonstration projects. As you may know, last year we completed the first flight between the 2 airports, and in Chengdu we use a helicopter to do that because helicopter is more about exploration, the mature project, and SKP. We fly to the demonstration airport and from the commercial center. That will be one good example for in replacement of the shuttle bus in airport. For the eVTOL in the future, in the past we may need to travel for 1 or 2 hours on the road, and now we can transfer all this time, shorten the time, and convert it into the time in the catering and also in the shopping. For Chongqing and Chengdu, the transportation can be hard because of the mountainous areas. Now we can shorten the time consumed in between so that we can bring about better traveling experience. That is also in line with the low-risk operation environment to do the eVTOL operation. As we mentioned, the first thing we thought about is how can we ensure that you can see some 80% of the world's pandas in a comfortable way. And we have different panda bases in Chengdu. In combination, some 80% of the world's pandas are located here. In the future, within 1 day, you can see all these pandas using the eVTOL. We also have the different kinds of commercial application for eVTOL, and I think one meaningful case is that compared with the general aviation in the U.S., the first 8 helicopters is only some 20% and lower of the U.S. amount. So there is a major gap between the two countries. For the patient, we have no idea about how to use the helicopter as the first aid tool. In the future, we hope that the eVTOL can empower the medical assistance so that we can have the more equal distribution of medical resources, in particular the Western areas who are protected by the new technology to improving the livelihood.
Thank you. That's all from me.
Thank you, Mr. Yu. And you were probably wondering, as we derivated a little bit from our schedule, because we had an issue as the next presenter, or actually the presenter before, Ken Coughlin from eVTOL, he should have been connected online, but there is an issue with the online connection. So that's why we changed the schedule a little bit and still hope to reconnect with him as he was connected earlier. And it's the same also, the next presentation from Diamond Aircraft Volocopter. It was an online-offline presentation planned. At the moment, we have our real presenter here, but I'm still trying to reconnect with David Bausek. So we all push Diamond Aircraft to the back as well. So the next speaker we will announce is Kai Wenkan, and you will introduce him.
行，刚才那个维尼说，因为有2位外宾演讲是在线上。
Two international speakers would later on deliver their presentations online, but due to some technical issues, they will be postponed to later sessions. So next we'll have Cai Wenkuan, the CEO of Dreamfly, and he'll talk about hybrid tilt-rotor eVTOL makes the world within easy reach. Like Mr. Guo, I came back from Dubai recently. I found an interesting phenomenon. So the more capable, the more open. For instance, Joby this time are willing to share with us lots of technical details. We have Pei Yu and Guo presented their slides earlier on. So we as latecomers, we also like to share our perspectives. So Dreamfly, we focus on hybrid tilt-rotor. That's our main focus, or only focus. And we hope we could lead the e-flight era and realize the flying dream. Our work is not as solid and specific as the leaders, so my presentation may be a little bit more general than previous speakers. So we started early. Our target is to have 1 technical path and 2 products. The first product is DF600. We'll have TC and PC by the end of this year, and DF3000 will get the TC by Q4 2028. We started quite early. Actually, the exploration of hybrid tilt-rotor has been a long journey. And starting from 2018, we started our own R&D. And now it's been engineered and converted. Ideas been converted to products. Last November, we realized the tilt-rotor transition test flight process, and this September we got the DF600 TC being approved. So we'll have the inaugural flight of the F3000 next February. So as you can see, lots of difficulties and lots of differences comparing to pure electric tilt rotor, and lots of work to be done. In the overseas market, Joby completed their hydrogen electric hybrid version eVTOL prototype last July, and Beta collaborated with GE to develop hybrid eVTOL this September. In terms of our own exploration, we have so far gathered cumulative flight testing and validation data from 700 flights. We have also made 30 key breakthroughs and iterated 20 versions. We have also been worked with ministries and SOEs to carry out joint research to try to improve the design as well as the hybrid and parallel tests. So we have also made this picture. As you can see, different tongues, different velocities, and this is the most optimal structure of different tongues of aircraft based on 2027's technological level. And as you can see, we have moved beyond academic research to practical analysis. We have also learned a lot from pure electric partners and peers. And based on that, we have did this picture from 2027 to 2035. So if it's less than 2 tungsten piston is a good choice. And from 3 to 6 tons, turbo shaft may be the good choice. And if it's larger than 6 tons, then pure turbo shaft would be the ideal option. So on the right, you can see the in-reality tests. We are willing to work with partners in the ecosystem to build the hybrid power system. You can see there are lots of hybrid companies, research organizations, and etc. Here are just a few examples. Here we can see Aerofugia and Autoflight and etc. Together we could develop a different market because low altitude economy has its own benefits. It's economic, it's probably safer, and we need to strike a right balance between cost-efficient, safety, and etc., so as to reach a wider audience. And here I'd like to share with you more examples. Well, first of all, we could bring better accessibility to remote areas, for instance, to Nujiang, to Yunnan. During the winter period, lots of those mountainous areas wouldn't be accessible. So when there are emergent needs, we could use such vehicles, such transportation method to deliver goods there. This is better than traditional heavy asset-based infrastructure. Also, we see about 2 billion populations still live in mountainous areas that are difficult to access.
从海权往陆权的一个拓展，但今天我们事实上让它服务了我们的民生和经济。
Also, it right now go beyond the military purpose and now could serve the society as a whole and the general public. It could allow more efficient commute connecting land, port, and the inland area. The cost comparing to traditional transport will be higher, but it could save time and save lots of effort. For instance, in Zhoushan area, we have lots of routes and also lots of fast delivery tracks. And we see a lot of potential areas where commercial values can be realized. It could radiate or cover an area of 300 kilometers radius.
基于语音，大家看到的是能通过海面的舰艇向90%的人口进行一个投送。那么今天我们能做的也是把我们的航道、海岸线。
But right now, vessels, they can reach 90% of the population via marine transport. And now we can use hybrid eVTOLs as the air capillaries, connecting maybe 60% of the economic output. I see lots of good friends in Indonesia recently or to Dubai recently. Actually, there is a lot of area for us to initiate collaboration. So another area for growth is the low or underdeveloped area, or those areas where logistics and the supply chain are underdeveloped. And this could also be a new driving force for the global economic growth. These areas, they shouldn't be called the third world, but areas with underdeveloped transport access. For instance, Xinjiang and lots of African areas. They have abundant resources. And to make these people and to make their lives prosperous, we need first of all build roads. That's the traditional understanding, but it's not value for money. It's not that cost efficient. So, for instance, in Rwanda, they now have a air-based national network to transport blood. So, such an area would cover about 1 billion population. But still, low-altitude economy itself is still a challenging topic. So we can start from certain areas as a starting pad and then work from there. So that was a bit general. We are still working on those specific scenarios right now, and we will focus on 2 to 3 of them moving forward to test the technological feasibility and etc. And I will report to you our progress later on, perhaps in next year's forum. So I hope we could together initiate the next generation of eVTOL development and hybrid tilt-rotor development. Thank you.
Thank you, Kai, for informing us about this
谢谢蔡总跟我们分享这个新的项目。我觉得这个项目呢，其实跟现在的新趋势也是密切相关的。那就是混动其实是一个非常真实的机会。现在越来越多的 eVTOL 的制造商，其实现在也在追求混动的方案，因为
having large ranges at the moment. So we will all hope and wait for the new best battery, but on the other hand, we are also looking into hybrid options. Our next speaker is Michael Thompson from UK, And the very interesting thing for me was when I came to Oshkosh this year, was for a long time a very new aircraft which I didn't hear about. I come to this place for more than 20 years, and normally I know everything which is going on the scene, but this was an aircraft which really had escaped a bit under the radar, and I was surprised. And it's also going the direction of something we talked already today, which is having eVTOL also in MOSAIC class at a lower level than passenger transport, but being in the air much faster. And I'm happy to have Michael here. And Michael, tell us about your project.
Good afternoon. Yes, so my name is Michael Thompson, CEO and founder of Skyfly. Oh, I've gone the wrong way. Yeah. So thank you, Willi, for inviting me along. It's my first time in China. And I've been blown away by everyone's friendly nature. I'm looking forward to coming back. So Skyfly is something different to most aircraft you've seen today. It sort of is a leap between a single-seat Part 103 aircraft and then the larger eVTOL types. And as Willi said, we're really lucky that MOSAIC has come out when it has, because we've sort of fit that market exactly right now. So pictured here is our first prototype that we've been flying since last year. It's called the Axe. So it's 2 seats side by side. So it's conventional takeoff, vertical takeoff, short takeoff and landing. And I'll come on to the design a bit more later. But yeah, so this is our first aircraft, and this is actually me hovering it in the UK. So we're based in Oxfordshire. So the ability to taxi, the ability to do the vertical takeoff, we think it's a very versatile design. So, yeah, I started the company in 2019. We've now flown around 50 times over 2 continents. So in the UK under experimental conditions, and now just a couple of weeks ago we've also flown in the USA under experimental conditions as well. We've got a small order book, but of real customers, people that have put down money, private customers, so private owners and operators. That is our initial market, to sell to private owners. So that's sort of the whole business case, was to be able to make something that's affordable, which is sort of where we get on to sort of where did we start and what was the problem we were trying to solve. So I fly helicopters, and I'm just shocked at the cost of doing so, and also maybe it's harsh to say, but they're quite dangerous. So for example, Robinson R22, very noisy, mechanically extremely complex. You've got a main rotor gearbox, tail rotor gearbox, a single piston engine, and that complexity means it's very expensive to run. They're also incredibly difficult to fly. I don't know if anyone's ever flown an R22, but they can get buffeted by the wind quite badly. So you have to be a relatively skilled pilot. And really, these aircraft that I've got pictured here, you know, from the 70s design-wise, and there's been very little innovation in this sort of space. So that's really where we wanted to enter the market with the 2-seat to replace something like an R22 or a Cessna 152. So introducing, yeah, the Axe. So it's a fixed-wing canard configuration. So there's a main wing at the back with ailerons, and then the canard on the front, which has the elevator, and then a fin and rudder at the back. Unlike lots of these eVTOL concepts, we are convinced that being able to glide and dead stick land is really important. We can have all the amazing electrical systems in the world, but so to that end, all these mechanical controls are mechanical, so they're not requiring any electricity. There's no systems that control your aircraft in forward flight. The only point in this, in the flight envelope that you're using any sort of electric stabilization is in the hover. And so really you're looking to build up airspeed as quickly as possible and get out of that sort of dead man's curve, very similar to how helicopters are flown today. So as I said, it's cost effective, so we expect the annual running cost for 100 hours to be around £7,000 a year, which is around £70 an hour. As I said earlier, given the configuration, we have no rotating motors. Another big thing for us was to make this as mechanically simple as possible. So there's no rotating motors. They're set at around 45-degree angle. So they enable you to pitch the nose up to enter the hover, or, as I say, do a conventional takeoff and landing or a short takeoff and landing. So it's very, very, very versatile in what it can do. So obviously, what the applications of this vehicle have been very much opened up by MOSAIC. So as Scott alluded to earlier, the sort of limitations for us to enter the market have been heavily reduced by the introduction of MOSAIC. So specifically the complete removal of the maximum takeoff weight, a stall speed which we fit well within, around 49 knots, the ability to have multiple electric motors, and also, interestingly, the inclusion of aerial work now with LSA aircraft. So with this aircraft alone, we can tackle a huge market segment. So anything from, obviously, the private ownership. This is really where we went into the market first. But they're not limited to pilot training. We've got a fantastic configuration, 2 seats side by side. There's a center stick in the middle, dual controls, so dual pedals for rudder control, and then two throttles either side. So it's a fantastic training aircraft. And we also see this potentially being a very valuable trainer to the larger eVTOL manufacturers. So then, leading on from that, you know, VIP transfers, light cargo transport, this is all in a piloted configuration, and then all sorts of aerial work that you could use this machine for. I haven't actually touched on it, but just to give you an idea of the range, we're 100 miles with a 30% reserve. So that's with a vertical takeoff and a vertical landing. So it's quite a useful range, and coming on to some unmanned applications where we're doing the hybrid version as well. So with this platform, we can very easily convert the machine to autonomous. The flight controller is actually the same going from the manned aircraft to the unmanned. All of the tooling is exactly the same. The whole airframe architecture is the same. So we can very easily unlock a whole new market as an unmanned vehicle, and also with the added hybrid system, which is a small gas turbine providing around 65 kilowatts of continuous power. So that in the cruise will give us the cruise power, and then we still use the batteries for that high power vertical takeoff and vertical landing. And yeah, as I said, it's a very modular airframe. The wings are removed in about 5 minutes. So it's very good for putting it in a container and shipping it wherever you need to use it. So the only difference between the unmanned and the manned version is that the control surfaces are driven by servos rather than a mechanical control system. Pretty much everything else on the machine stays the same. We've got a triple redundant flight controller, and then the ability to configure this aircraft with whatever payload you require. So yeah, you can see the turbine exhaust at the rear of the machine. So this generates 65 kilowatts of continuous power, a cargo hook at the back as well. And then interestingly, we can also use this machine as a on-ground generator to provide power to remote areas. So you leave the turbine running and then you can provide power to whatever you need on the ground. So where are we and where do we want to be in the next sort of 12 months? So as I said, we've just sort of coming to an end of our test flying of that first prototype. There's a number of things we're changing. We're upgrading the propulsion system. We're upgrading the battery system. Some structural changes we're making, changing material type, all to essentially become completely type conforming to the LSA standards. So essentially by the end of next year, we want to have been LSA certified with our second airframe, which is currently in build in the UK. I'm just going to briefly talk through the team. I'm going to just touch on two key players that have really facilitated this journey for me. So my background is in drones, but I wanted to talk about William Brooks. So he's our CTO. He's designed over 19 different aircraft with over 2,000 designs of his still flying today. So Bill has taken my idea and brought it to life from an aeronautical perspective with his design skills. So really we're lucky to have such knowledgeable expertise in aerospace design to really refine the aerodynamic characteristics of this aircraft. And then St. John Youngman. So St. John is best known for his work with breaking the electric speed record in partnership with Rolls-Royce. So that was the Axel program. So his company, Electroflight, developed all the battery systems and propulsion system for that machine. That's now eVTOL. So St. John's come on board to help with the upgraded propulsion system and battery system that we're doing on serial number 2. So yeah, we've got a really good team around us that are developing the aircraft to become type conforming with the LSA standards. That's everything from me. Thank you very much, and see you later.
Thank you, Thompson, for your sharing. Indeed, we can see all kinds of novel aircrafts in different spheres. For eVTOL, low altitude flying for different scenarios application, the market is highly niche, so we need to use different types of aircrafts to meet the demands. It's not like the transport aircraft, and now the aircrafts are more versatile. We need to match them with different functions. Each aircraft may find their own niche market. Based on needs in the market, we'll do the market development. Our next speaker is the GovTech of the GAC Vice President Zheng Jiaxiang, who will share with us on building an intelligent LAE ecosystem. Let's welcome Mr. Zheng. Good afternoon. I'm Zheng Jiaxiang from the GAC GovTech. For GAC, and we are based in auto industry, and we also call the GovTech products as the aero car. We hope to construct the reassured and one-stop intelligent LAE. Now we have some pain points. The first one is that for the LAE, it's built upon safety and affordability. We need to balance the two elements. That is the core message we want to deliver to this meeting based on our experience. For LAE, based on the just concluded the fourth plenary session in the CPC Central Committee, injected the impetus into the development. In the 15th five-year plan, we plan to view the LAE as a pillar in the future to have the multiple trillion industries or even larger strategic market. It means that last year we proposed the 2035 3.5 trillion scale. In 2030, by the end of 15th five-year plan, we should have some market scale of some 2 trillion. In the 5 years, how can we innovate the institution to use the product to drive the industry so that we can further improve the compassion capability to realize the vision so that we have the strategic pillar for LAE. That is one exciting news from the official news.
eVTOL, or flying cars, is the golden track in LAE and the pearl on the crown. Why do we say that? Well, new energy and new vehicles been developing for 10+ years. And right now, 1/3 of the electric vehicles are sold from China. China's transformed from a small vehicle producer to an electric vehicle power. So how do we catch up? In the same way, in eVTOL, this is something we need to think about. eVTOL, or flying cars, could electrify and make intelligent development further based on the experience we gained from ICT and from automobile development. Is a cross-disciplinary industry. Hence, we believe flying cars or eVTOL are the most important platform for developing LAE. It allows a quick vertical landing and takeoff. That's its most prominent feature. It does not require runway. It's more environmental friendly. It's more efficient. Also, the electric propulsion and the smart development makes it more smart, more economical, and safer. So it's safer, more environmentally friendly, more efficient, with lower cost, lower noise, and better safety guarantee. It also has high technological barrier and high entry threshold. So aerospace, UAV, and auto manufacturers and industries all want to pursue eVTOL because we understand, because we know that the scale of future eVTOL development is immense. And time is priceless. So eVTOL would, I believe, account 1/3 of the future LAE. So there's a great development potential in this area. So we have players of different background competing within this landscape. For players with auto experience, they have already gained 10+ years of experience. They have got mature upstream and downstream suppliers, and they also have solid industrial infrastructure and bases. So they are more advanced in terms of safety-related technologies. And lots of the domestic suppliers, they are no worse, or they are sometimes better than their foreign counterparts. That means safety and reliability. And second is we need to ensure eVTOL is comfortable and economical. how can we make good use of those new energy bases and the smart network bases? How can we ensure those products they are economical, comfortable, and cost efficient, and safe? And how can we catch up in this area? Guangxi in 2021 June has already started its eVTOL research and its journey. Flying cars in general sense include eVTOL. And if we look at eVTOLs from a broader perspective, then eVTOL means not just flying cars, but other formats as well. Many car manufacturers have also embarked on the journey around similar time period, but back then they were reluctant because back then it was too early. But Guangxi, we base in the Greater Bay Area, and we give strong support to our R&D team. 2024 can be seen as the year one for LAE. So based on the last 4 years of investment and efforts from 2021, we now have established this brand, Govi, and Guangxi Group, GAC Group, is the largest shareholder of Govi. This Govi Tech Innovation Co-Limited allows more flexible mechanism and enjoys a bigger investment, hence allowing faster iteration, airworthiness certification process, and industrial commercialization. It is based on the independent R&D of a GAC group. It has a mature and intelligent customer interaction platforms and a mature automotive industry and ecosystem chains provided by GAC Group. So far, we have already got over 70 manufacturers in China focusing on the whole eVTOL machine development and manufacturing, and we are one of them, and we are a SOE. We provide you the SOE quality and a mature network and supply basis. This is our company's profile. So we've been ranked as top 500 for several years in a row, and last year we sold nearly 2 million cars. So on the left, we have the air car with multi wings, and on the right, we have the air jet for mid to long distances. And the left is for short distance, low altitude tours and leapfrog travels. After years of development, all these vehicles have passed the tests on safety and range, etc. We have also set enough redundancies for these vehicles. 90% of the components use new materials, and right now the R&D has been going quite smoothly. The first is a separate structure. Is based on a separate structure. It was first shown in the Zhuhai Air Show. And the bottom part is a mobile charging and mobile takeoff and landing platform, and the multi-wing part is a unmanned cabin. It allows 30 minutes driving or flying and 30 kilometers distance. You could also see the prototype in the hall. On the right, we have the multi-wing. It allows 4 passengers, 200 kilometers traveling range. And it could be extended to 400 kilometers once it's equipped with a solid-state battery next year. And we are now working on these 2 products in parallel, and both have achieved a certain commercial success. Aircar has been flown for 2,000 times. Aircab got accepted by CAAC earlier this March, and Airjet we formed the TCB committee in May for Aircab. So in terms of certification process, it's moving rapidly, and we will get a TC by the end of next year for Aircab. And in the second half of next year, we will start working on the mass production line, and by the end of next year, we will start mass production and delivery. Starting from 2027, it will be used for commercial purposes. And for Airjet, it's been studied for 3 years, and so far we had about 200 trial runs. We got the special certificate for Airjet. So in a nutshell, this development is echoing the national strategy. From remote suburb to near urban and to urban. So as you can see, from short distance, low altitude tours to medium to long distance intercity travel, we cover all the categories. And the most competitive product for low altitude tours, other than the products from Autoflight and Fugia, should be able to cover 300 to 500 kilometers. So safety and cost efficiency are 2 things that we must strike a right balance between. So we can use those superior elements to ensure safety, but what about cost? How to increase the cost efficiency, especially in the downstream area? And here I'd like to report to you some of our thoughts. First of all, you need to independently develop those core technologies, because this is a complex system and a complex integration. All the core elements need to be developed in-house. You don't want to rely on those suppliers, because the quality is beyond your control, the cycle is beyond your control. So all the core technologies, for instance, the centralized electronic architecture and etc., are all developed in-house. The second is the motor battery, and those designs are done in-house. We can quickly charge the vehicle within 25 minutes, hence allowing high efficiency. And thirdly, L4 can be applied in those eVTOL vehicles, allowing low altitude obstacle detection and obstacle avoidance. All of those are our core GAC technologies developed in-house. And second is we have an automotive-grade supply chain. 70% of the components come from the automotive supply chain, and 95% are domestically manufactured. So this allows us to better control the cost. And third, we need to shorten the development cycle so as to accelerate the certification process. so as to significantly shorten the development cycle and save the testing investment. This is the test facility in Shaoguan, about 8,000 more.
The fourth part is about why we have the dual structure. And now we're seeing a fast development in terms of the multi-rotor and the aero car utilized in tourism and culture in low altitude transportation. By the multi-rotor aero car, the flight verification and the mass production in the future will be like the cost reduction effect for the composite wing aero car. In terms of the cost control, there is an empowerment from multi-rotor. That is the summarization based on our experience to have the safe, reliable flight. Apart from the motor, what is important is about the cooperation with all the ecosystems and the suppliers. We need to co-develop the ecosystem, namely infrastructure and operators. We need to jointly promote the whole ecosystem and supply chain. So there is a future-proof the smart low-altitude commuting and traveling. By one instruction and the mobile phone, we can have the one-stop service. In the future, by clicking on the mobile phone, we can get the taxi, air taxi in the future. So since this year, we've been promoted the demonstration plan for the aero car in Greater Bay Area, headquartered in Guangzhou. We are already waiting to the central and the western part of China, even the northern part. So by joining hands with ecosystem suppliers and partners, by the end of last year, before getting the TC, we have the demonstration commercial scenario deployment. So we're thinking about all these commercial ideas. For instance, in Guangzhou, in terms of the manned aircraft commercialization, we're kind of pushing the process. By the end of last year and the 2 years later, some competitors may get certification. But before that, what we need to do? And after the certification, how can we transfer from the demonstration operation to normal transportation? So now we're joining with transportation infrastructure and operation partners to pay more attention to 5A or 4A scenic spots in China to build scenarios by the static or the traveling or visit and the learning process, and we combine them with the dynamic traveling and the flight so that we can have the demonstration, testing, the sales operation, OMM, the GAC, manned aircraft demonstration base. That is the model based on our cooperation. By 2027, when we get to the certification, we can transfer to the static and to the dynamic and normal operation. So such a thinking is not the thing that is not unrealizable. Instead, it is based on commercial judgment. We make some commissioning or deployment beforehand. So I hope to join with all the partners to construct the one-stop smart traveling ecosystem. Thank you.
Yes, hello, and now we have a slide change again. So now we will have Diamond Aircraft presenting for us. We know they work on a fixed-wing aircraft, and you will wonder what does they do in the eVTOL section. But as they are a company working now, since they took over Diamond Aircraft, took over Volocopter, sorry, in this year, they now do both. And so we will have a dual speaking. So we'll have Xing Shuangxi speaking about the fixed-wing aircraft of Diamond Aircraft, and then we will have the CTO of the company, David Bausek, joining from Austria online and giving the latest development on the VTOL side. So come to the stage. Thank you, Xing, and
hope to hear some informative news from you.
Distinguished leaders and dear colleagues, good afternoon. I'm the Xing Shunxi, the flight department. I want to share with you, and from the Wanfeng group, I want to share with you about the fixed wing development. Our company was founded in 1994, and we position ourselves as the international manufacturing group. And in the transportation, we have two sectors. One part is components and parts of automobile. Another part is the flight and aviation. In 1994, we started from the hub of the motorcycle. Then in 2015, I acquired the diamond, and we entered the aviation industry. In 2025, and we acquired the volocopter, and we expanded to the eVTOL. Globally, now we have 6 manufacturing bases, including Canada, Germany, Austria. In China, we have the Qingdao, Xinchang, and Suining manufacturing bases. We have 4 R&D centers and 3 flight schools. Globally, in more than 90 countries, we have 192 service centers. That's for diamond aircraft market share in the world, 20%, ranking the second in terms of sales in the world. Wanfeng Auto, in terms of hybrid and e-aircraft and eVTOL, and we have a deployment in R&D. And now we have the light sport aircraft, the flight training, the private flight, and the utility. For Diamond, in 2011, started the hybrid aircraft R&D. In 2013, there is the performance boost. In 2018, the maiden flight, the first dual-engine hybrid-powered airplane. In 2021, we officially promoted the EDA40 development announcement. It is based on the Part 23, and we had the Pure E aircraft. 2023, we had a maiden flight. We expect in 2026, namely next year, we can get the EASA certification, TC. EDA40 is based on the DA40, the 4-seater. It is a brand new product. It is the first electric airplane to apply for the EASA Part 23 certification. The model is equipped with battery module, charging 20 minutes, endurance can reach 74 minutes. Compared with traditional piston aircraft, operation costs can be reduced by more than 35%. That is the EDA40 basic parameters. Currently, it is a 2-seater. After upgrading the battery, it will be like 3-seater. The endurance is 217 kilometers. The motor is from the Siphon. The largest power is 125 kW. The efficiency more than 94%. The power has been certified by EASA. In terms of battery, we adopted the 80 kWh battery system, ensures an endurance of up to 74 minutes. We expect to get certification this year. The aircraft is dedicated to the flight training because there is the VFR and IFR capability. Operation cost is low. The cockpit arrangement is exactly the same as the DA40. It is the 2-seater, 2-control configurations. The DA40, DA42, there is the perfect flight school training system. Thank you. That's from my side. Now let's hand over to David.
I think, David, you're still muted. Hello?
Can you hear me now?
Yes, now we hear you.
Okay, perfect. Thank you, ladies and gentlemen, for the opportunity. I will share my presentation. One moment. Can you see my screen?
At the moment, we do not see the presentation yet.
David, we don't see your shared screen. We don't see your shared screen.
Okay.
Could you try again? Click.
Yes.
Yeah, now it's
see. Now I see.
Perfect. Thanks for that. Now you can see the presentation.
Yeah, now it's full screen. Yes.
Perfect. Thanks for the opportunity. We are very happy to join this presentation and this event here. So I'm located here in Germany at our headquarters. So both headquarters are in Germany. We are producing eVTOLs. So myself, I'm so in our group, we have more than 1,500 aircraft, very famous for fixed wing. So we are the #2 in general aviation. We are doing single engine and twin-seated aircraft up to 7-seated. And we have aircraft outside and certified more than 20 models worldwide. So why Diamond Aircraft has acquired Volocopter? So that's the question. So we have started already 7 years ago with developments on eVTOL together with large automotive partners. We have also shown this in many air shows, also in China, also in the last air show in Zhuhai, and we have also launched in China different models and flown eVTOLs up to 166 for 4-seated designs. So Diamond has with eVTOLs with the main idea starting with the conventional aircraft. So the next step is the electric aircraft and the eVTOL. And at one point, we will combine land aircraft with our eVTOL technology, which means that we can achieve the same range with vertical takeoff, horizontal flying, and vertical landing as we have now with our eVTOL. So now we are talking about short ranges between 30 kilometers up to 200 kilometers for eVTOL. Once we have combined these technologies, we are talking about 1,000 kilometers or more. So that's our strong synergy between the technologies. Then also Diamond has a long history in certification of aircraft. So this builds a very, very strong organization as one as a unique fusion between Diamond and Volocopter, because we are the only one who have certified already and an eVTOL, yes, it's a new certification specification, it's FAA. However, the road for the certification remains the same, and our experience and our knowledge of Diamond Aircraft can be applied in Volocopter. We have also all organizational approvals which are necessary, starting with POA, ATO, Part 145, Part 147, so everything what is necessary for aircraft production, OEM, development, and also operation we have in the Diamond Group, and we have a very, very strong foundation in supply chain. So that means we have factories around the world, and also we have an established aviation supply chain. So our factories and our development centers here in Canada, Germany, Austria, and China, we host more than 70 nationalities and about 250 engineers. So coming back to Volocopter, so Volocopter has a long history also, established in 2011, and then built the first unmanned aircraft. It was the first eVTOL in 2016. We have also in Volocopter as an own entity, design organization, production organization, organization. So all the organizations are part of the group, as well as we have different models also established and flying in our production center here in Germany, which hosts a velodrome and vertipad, as well as an airport itself. We have conducted more than 1,500 flight tests at our airfield with our models, most of them already with EASA and local authority witnessing, with the one goal to reach TC in 2026. So we have also flown all around the world, also in other cities you can imagine, except in China. In China we will do within the next week. So what are the core values of Volocopter? So we are the safest, and that's it. This is really the core. This is also the synergy between Diamond and Volocopter. Diamond is famous for being the safest aircraft in aviation. So that's proven by many, many statistics over our fleet, over the 6,000 aircraft outside. So Volocopter will design, and it is designed in the same way, most safest coming from the architecture, so supporting redundant rotors, the redundancy of the systems. It's not only redundant, we're talking about also dissimilarity. Also for the design assurance level, we are developing the local standard, so to design assurance level A, which is required for commercial operation in Europe and in US. So this package gives the safest eVTOL in the world. We are also one of the quietest because we have more engines than most eVTOLs, so this gives us a very low system because low overloading leads also to noise emissions. And we are realistic. We're flying for in EASA certification more than 4 years. We are in pre-LBA certification, so that's the local authority of Germany. And we are at the last milestone before TC at EASA. So this makes us a robust solution for the eVTOL market. We have not only one product, we are looking at a portfolio of products. So starting in the 600 kilo class, going over commercial 1,000 kilo intra-city transportation and taxi, and then going into the region to 100 kilometers, and then in the regional transportation go up to 400 kilometers. We also have a product like Volodrone and VoloIQ. VoloIQ builds the backbone between our product together with services and also. So here you can see our lineup. VoloX Pro at the bigger city, our core products, which are under development. Especially the VoloX Pro. It will also fly in China. So we have plenty of test flights. Our setup that one prototype always remains the same. certification on time. And Willi explores the main differences in the architecture. So the Velocity will be certified for a full commercial operation according to the eVTOL advanced category, while the Explorer will be certified under local European authorities, and then also received in China. For Volo Urban, we are looking into far range up to 100 kilometers, and the Volo Region ends up our portfolio up to 200 kilometers. You can see also below our market entry. So nearly completed. So it's following the local certification. So it will be possible to be sold next year. And then we have the Volo City, which is targeting TC date by the end of 2027. And then we are looking for Volo Region in 2028 entry into service. So the Volo Explore, 600 kilo, two-seated, especially focused on mobility for everybody. Because of its architecture, it's super easy to fly. With the 18-volt motors, it's low downwash and also low footprint. The rotor there are no obstacles for any rotor blast in case of passengers entering the aircraft or also surrounding the aircraft. We have a very high landing gear, which absorbs a lot of energy. So this gives very, very good behavior in case of any crashworthiness. So the package is sharing the most systems with the Volo City, making it for a very, very safe aircraft, which rounds up our core identity. You can also see here we have received a special flight permit for China, and we will demo also the aircraft in China. The Volo City, it is our air taxi for intercity transportation. Highest level of standards, 10 by the power of eVTOL advanced category certification. 30 kilometers plus, battery versions starting from super long battery, which gives more than 30 kilometers, and then up to maximum payload batteries, which gives up to 200 kilometers. So the Volo Urban, so this will enter into the category up to 100 kilometers, and to be market ready in 2028. And then we have the Volo Region. The Volo Region is a lift and cruise configuration, very similar to the product what Diamond has done before, together with our automotive partners, the Vimo. So this will have wings and also vertical and horizontal pushers, and will go up to 200 kilometers. So if people who are watching us, they already know what cabin design we can do, because we have displayed on last two high. So aircraft at the same time of different types of aircraft. We can fly Volo City as mine, so we can fly so aircraft autonomous ready. This means we can fly fully tested, but we will certify because of the regulations here in Europe. But once it's ready, we have shown that autonomous capability of the aircraft, so we can just then swap our aircraft from one to two modes. The Volo Urban and the Volo Regional also play a major role outside of cities. So where are our customers in our market? So we are looking at tourism, private flights, emergency medical applications. We have there also lead customers in the medical service, and then we are looking at intra-city connections. We have shown that in Paris, infrastructure, the airport with cities and district cities. So that's everything for today. Thanks for the time. And a further debate. Thank you.
Thank you, David. If you could stay online, it's just one more speaker, and then we have a panel discussion with questions. So if you just stay online, we put you off the screen and we get you on back as soon as we start the panel in 15 minutes.
Yeah, perfect.
Thank you. And now we're going from virtual real again. Our next speaker is Gu Hongyang. He's Chinese, but he also has his company in the United States, so he's very typical for what e-flight-Forum wants to achieve, to bringing the world together. So, David, tell us a bit more about your project. Stage is yours.
Hello. Hello everyone, my name is Gu Hongyang. You can also call me, I'm another David, by the way. Just really quick before I start my presentation, I want to start with a personal, wait a second, does it work? Oh. I want to start with a personal anecdote of mine. So I learned how to fly in the United States, and that was when I was 18. I was a high school kid. So my flight instructor called Justin, who is from the family of aviation, right? So his grandparents worked for TWA. So his grandfather flew for TWA, and his grandfather owned a Beechcraft Bonanza. And his father worked for American Airlines, and his father owned a Cessna 172 RG, that's for retractable landing gear, cutlass, right? And for him, which is about the age, so he was born in 1994, so he's about the age of 20-something when he was teaching me as a CFI, right? So he could not afford to buy any aircraft because I asked him in a very awkward situation. So I was trained in the 1970s Cessna 172, retrofitted with Garmin G1000. The plane is very bad, and the weather, it was just like that this November. It was really cold. I was priming this plane and got the cylinders flooded with avgas. So we were just sitting in the plane, and it was really cold outside. I was asking him, why didn't you have enough money to buy yourself an aircraft? Well, painfully, it's just the economy and the sad reality of general aviation is that the inflation has brought up the price of aircraft so high that he, as a 20-something-year-old man of CFI, couldn't afford to buy a plane. So that got me started with this project called Landback. So it's a bunch of kids, 20-something, just like me. We're from the University of Washington in Seattle. Some of us are from Georgia Tech, and some of us are from Stanford. So we want to make an electric eVTOL that is a personal aerial vehicle. That's a personal aircraft that is part wall free, ultralight. So we're try to cram all the technology that you guys saw in AutoFly into a airframe that has a maximum takeoff weight of less than 300 kilograms. So first, let's start with the problem. So the problem is very obvious. Well, that's the problem in the United States. Very soon, that's going to be the problem in Europe and probably in China and as well. So first of all, it's the pilots and the planes, right? There's these aging pilots and aging fleet. So the general aviation fleet in the United States is very old, and you see these really old Cessnas. The example right there is 1965 Cessna 172. But it costs $120,000. That's a lot for a middle class or even an upper middle class family to own an aircraft. So because the pilots are getting old, the planes are getting old and expensive, and also because of the inflation that is getting higher, and the actual buying power of the aviation product consumers are getting lower. So we're seeing this the effect of young people are not buying aircraft or not flying that much. So the result is that the younger generation can barely afford to fly. They cannot, simply cannot afford to own a personal aircraft. And they don't have, currently, they don't have the right aircraft or the incentive to maintain such a flying hobby. So that is the current situation in the United States. So, but if we look back into the 1960s and 70s, things used to be really good, right? So you have this chart on the right side that is data from Gamma. That's from 1950, late 1940s to 1976. You can see each year there are thousands of planes being made and delivered. Things were being engineered and being made at an incredible pace, while with innovation, of course, not with not with the current situation of stagnating technology, right? So from this thing, we can see that the demand for this recreational sport aviation is still there, but we see that the pace of delivery of the GA fleet has slowed significantly. So so what we are trying to do is that we want to supplement, or not replace, but like supplement the current GA fleet, and those who want to experience flying but have a relatively low budget, but also want to try something new. So currently there's about 50,000 Part 103 outside in the States, about 13,000 registered LSA in US, and there's some experimental and legacy GA aircraft. And these aircraft are the planes that we intend to replace as they are being phased out. So our solution is a ultralight Part 103 eVTOL. So it does land on water, so it has the boat hull and small floats. The maximum takeoff weight can go to 280 kilograms with 250 pounds, and which is 113 kilograms of maximum payload. If you want a bit more payload, you can add 2 extra floats onto it, making the MTOL up to 295 kilograms. So it is a lift plus cruise flying wing. So the thesis behind it is that we wanted to fly nice and slow, and we wanted to have it fly as long as possible. For the flight duration, we have about 2 hours of rated flight time, and during the cruise, the noise, if you listen to it from the ground, it blends into the environmental noise very well. So it's equipped with a ballistic parachute, and also has a triple modular redundant flight controllers. So it is a SVO, so-called SVO standard eVTOL, I would say. So yeah, so this is our concept, and so we have verified via our subscale model that we have a glide ratio of more than 20. So we will improve our glide ratio, and we will try to get to that glide ratio as much as possible when we have the real full-scale aircraft. So it's designed to cruise very efficiently, so but not in a very fast speed. So the enabling factors behind this concept is basically you have this supply chain of these large agricultural UAVs. So they're around Shenzhen, around the Pearl River Delta region. So they enable the cost of the eVTOL propulsion unit to be very, very cheap. And they're already enjoying this economy of scale because they are being produced at a very large number, right? So for the eVTOL and cruise propulsion units, they are already there. So it's just a matter of quantity, whether we can sell them or whether we can have them deployed at very large quantities. And that's when the production cost is going to get even out, and that's when the cost is going to get low. So, and for the avionics, for the triple modular redundant flight control system, so we are aiming at around $3,000 per piece. So because of the consumer electronics and the advancement of the chips in the EV industry, so we are actually designing an in-house triple modular redundant FC so that it is cost effective, or it can also maintain the flight safety level of 10 to the -5-ish level safety. So that's about like 1,000 hours per year and airframe lifetime of around 10 years. So for the airframe, we are using the carbon fiber affordable composite and carbon fiber from the wind turbines, actually. So these carbon fiber manufacturers, or these makers, are already used to making the fan blades of these wind turbines. So they're already very skilled, and they can produce them at a very large quantity and at very, very, very low cost. So it is this advancement, not only in tech, but also in the cost effectiveness of tech, that was something that enabled us to bring out this affordable ultralight eVTOL. So our vision is that you, as the aircraft owner, will be able to enjoy this, whether it's weekend flying and barbecue in the Class Golf or Class Echo airspace, or over a patch of grass or in some scenery places, or whether you explore the terrain or the natural wonders around the world. So this aircraft will be a tool, or will be something that will help you to realize that type of freedom. So we have completed the SFT, and it flew for around 4 hours, and the range is about 270 kilometers. So we are currently working on the full-scale prototype. Oh, by the way, because we are a American company with a Chinese supply chain, we actually have this dual-track supply chain that has to minimize the geopolitical risks. So we have, so for every component, we have a Chinese supplier and a Southeast Asian or Mexican supplier, so that even at 112% tariff, we still have a fairly high gross margin. So it's the playbook of a lot of these consumer electronics companies in Shenzhen. So yeah, we have the full-scale prototype in progress, and the flight test is scheduled for Q1 next year. And in Q2 next year, we plan to have a Llama TSC, which is a testation that we comply with the FAA's Part 103 regulation. So that's it. And these are the QR code for LinkedIn, WhatsApp, and WeChat. And thank you very much.
So thank you, and please stay for the stage, David. Please stay here because we'll get the panel discussion now, so you can get ready for questions for our presenters, which we have here. And I have a lot of questions, as there is a lot of interesting stuff. Maybe you can put up the David from the Zoom back on the screen again. For the panel discussion, so maybe you can tell them. Yeah, and Xin, you could ask for putting David back up on the screen with microphones, one more chair, and then we are ready to go. So, Michael, come up. And Xin, from Diamond Aircraft, I don't see him at the moment. Ah, here, sorry. You can come up too. So, 1, 2, 3, have a seat. This time I sit. Yeah, like you want, just one. And David, yeah, is up. Everybody has a mic. Yep. So put this one away. And we can start. Have a question for. Oh no, maybe it's good to get the translator if you have a question from the Chinese audience. I start with an English question first for Diamond Aircraft. Like on the eVTOL, I saw very concrete. Let's say you want to go to market in 25, 26 with different products. When will be the EDA-40? No, now they take away the chairs. No, stop, please. I know it's one too much. Anyway, no, it's my mistake. I'm counting wrong. Anyway. I think the chairs don't matter. So yeah, when do you think you will go to market with the EDA-40?
2006年我们计划。
2026.
Okay. And the primary target of this aircraft will be training market, right?
Yeah, training market.
And question. Oh, now David disappeared. David. Because I had a question on David, I think they put you off the screen again. But are you still there?
Yes.
Yes, I'm still there. Okay. Okay, now they know you're back. I have a question. As you mentioned, you have the X. You first have, or you waiting for the German ultralight certificate, and at the same time, I heard, you mentioned that you're going to fly in China. So I heard that it will be probably next week at the Aero Asia. Is this correct?
Yes, that's correct. We are very proud that we received the special flight permit, and we are looking for a cool flight demonstration on the Aero Asia. And our aircraft is still on the ultralight certification in Germany. So we are progressing there very quick. So we are looking for entry into service in 2026.
Okay, and will there be some, let's say, product or supply chain overlap between Diamond Aircraft and Volocopter, or are there at the moment still two different worlds?
Well, we are trying, and we have also already switched some of our suppliers to Diamond aircraft suppliers, especially when it comes to aviation grade systems. So there we can utilize the supply chain from Diamond aircraft. We can also share our leverage to make our products more cost competitive for the industrialization of volocopter.
Okay, thank you. Just to the audience, we have more mics. If there is anybody who has a question, please stand up and ask. We have the microphones to bring you the microphone to ask your own questions. While we are still waiting here, I have a question to Michael. When do you think, because that's always a thing which interests myself, when do you think you will be ready for the market, when you can fly the aircraft, and when I can test fly the aircraft? Because I'm still a pilot, so I want to fly as many aircraft as possible.
So, as I said, we're doing some upgrades. So the next airframe is going to be a whole lot different. That serial number 1 I mentioned that you saw the video of, there could be an opportunity next year for us to do some passenger laps in that, just to give people the feel of how it flies, just as a conventional takeoff fixed-wing aircraft. But we're currently in build of the next airframe in the UK. So by summer next year, that will be finished. So then we'll be flying everything with the new systems, the new batteries. So our target is to, by the end of next year, have, assuming the LSA and MOSAIC goes as smoothly as I hope, we hope to have the first LSA permit on our aircraft by the end of next year.
Okay.
And then that means that you can hop in it. So we're going to do a first run of 5 at the end of next year. We'll start them.
And production will be, you know, nowadays with the tariffs, you never know if you have to produce in the market or not, because so would the aircraft be, or next year the first 5 probably in UK, but on the long term, as probably the largest market will be United States, at least at the beginning, would you then also look into a production in US?
Yeah, so we, as you say, the first few aircraft will be done in the UK, but 70% of our customer base is in the US. So we will have a facility. We've already established where that facility will be. We haven't announced it yet, but in the US. And that's, again, just composites. So we're doing all the composites ourselves, and then utilizing key propulsion systems from various suppliers. So, yeah, we try and, the one part of our production line we can completely control is all the composites, so that's what we will do ourselves.
Yes. Question of this, like, I think composite production is very interesting, especially when we see where we are here, and the whole southern China, if you see that, I think most of the advanced composite production worldwide is probably done in this region for all different kinds. May it be car manufacturers, may it be aircraft manufacturers. So for everybody, maybe starting with David, Volocopter FA, do you do any composite production for the Diamond aircraft already in China, or is this all done in Austria? Or and in Canada?
No, we have for Diamond aircraft 2 factories, one in Zhejiang province and one in Qingdao. We have also one more factory in Guangzhou, where we produce single-engine aircraft, 4-seated and also 5-seated. So here in China, we produce also for the worldwide market. So we export our products, especially DA50, which goes US market, European market, and also Asian Pacific market. And DA40, that's the 4-seated, especially for flight training aircraft. So this one goes out of Zhejiang into the local Chinese market and also into the Asian Pacific region. And we are doing here in China composite So starting from zero, from the dry fiber up to the full aircraft, full final assembly.
Okay. The other, I always call you David because you're only Chinese, as I know you as David first. David Gu is fine. Yeah. Okay. So you mentioned this in your presentation, but the first productions of the aircraft, as you're based in Shenzhen and United States, where will the airframes will be produced, the composite?
So the initial batches will be produced in China. So we want to, well, unfortunately, Ken Coughlin is not here today with us, but we want to, we have learned from Pivotal that it's very important to start with a initial batch that is pre-production, that you also work closely with your customers to have like 12 to 24 aircraft. So and so to have them experience the airframe, and if there are any small issues, we want to iron them out, right? So yeah, so initial batches will be made in China, obviously, but some of them will be shipped to the US, and there will be well, there will be test flown, and they will show their compliance with the FAA Part 103 regulation.
Okay, I have a question from Michael and also for you concerning, like in ultralight, there was traditionally used parachutes. Would you have a full airframe parachute on board, like a BRS, ballistic recovery system?
Yes, it's an interesting one. Obviously, our whole system architecture means you can glide and land safely without any electrical power. So it's not essential, unlike some other software critical designs, I would say. So they're reliant, continued flight is reliant on their software. I think it's more important to have a ballistic parachute installed. But for us, it's you've got that safety system of a glide. So it's going to be an option for customers.
Okay, and David?
So we have both, because we are a very light aircraft. So we have a higher glide ratio, and we did a 240 feet drop at 0 speed. So that's like assuming all the VTOL propulsion units have failed. So it'll accelerate, and it'll smooth out, and it'll glide itself and land at around 50 feet-ish altitude. So that's the gliding capability of it, and apparently it is very important to have that when you're flying something that is slow and low. So that's that, and also we're having this the CAP system or BRS or ballistic parachute or whatever. This thing, well, the maximum deployment airspeed is about 60 knots. So it's like a low, it's very low speed compared to like BRS for the Part 23 aircraft. But it is already enough for us. So because we are Part 103 and we are limited to fly below 55 knots. So that's what we currently have.
Oh, okay. I know there is another question, but I would have this question because I had this several times and I asked it to the Diamond owners, designers over years, because in a time where Cirrus was very successful with the ballistic parachute on board, where other aircraft had their maybe, or the Volocopter also had, as I understand, the ballistic parachute on board. Is it also an option that at some point there will be Diamond aircraft with a ballistic parachute?
So I can answer that if you like, or Dr. Xing also knows. So from Diamond perspective, our single engine aircraft by the record is in a very safe condition. There are also coming up new features which are full auto land, so in case the pilot is incapacitated. So this gives already a pretty safe package. However, I will not reject that. So in the future, of course, we can look into parachute. However, Diamond philosophy is always, as long as it's an aircraft and it can glide, and it has also other features which are enhancing the passive safety of the aircraft. So that means good behavior or good characteristics in stall, and also good maneuverability in difficult attitudes. So as long as this passive safety is installed, each pilot, as long as he's available, can still control the aircraft and land the aircraft on any field. So once he's incapacitated, we have now new systems which are full electronic, so that the aircraft can land automatically. And additionally to that, maybe in the future, also a parachute can be an option. For volocopter, I can answer. So in the ultralight category, there is the requirement, especially locally in Germany, that parachute is mandatory. So there we have a ballistic recovery system, which then also comes in for Chinese versions as an option. And for the Volo City, as it's designed to design assurance level A and 10 by the power of -9. So even in SC eVTOL enhanced category, so there is no requirement for a parachute. However, it might be an option in the future.
Okay, there was a question here.
Okay, yeah, here are some questions. 好，各位前辈大家好，那么我也是来自一家深圳的
Hello everyone, I come from a Shenzhen eVTOL company. Last time I met Mr. Gu in my company. I've got two questions. The first question is, for passenger carrying eVTOL, given China's mature infrastructure, how can it compete with subways? How can it compete? How can eVTOL compete with subways? Well, personally, I'm not that interested into that area. Initially, I hope my eVTOL can be a recreational vehicle instead of a transportational vehicle. The metrics for public transportation is quite standardized. People compete against the same indicators. So they are part of the whole infrastructure network. But for me, I hope to provide you a differentiated experience, a different perspective. So that's my thought behind my flight.
The question is, like, well, he asked me, like, what's the perspective of the eVTOL in this in China, where there are already this high-speed rail train and all the infrastructures. And my answer is that I think eVTOL is something to bring the joy of flight to everyone. And I think it could be something that is something totally new, and it could be built from a brand new perspective.
We have translation. It was translated in your.
Yeah, 不用那个，它有自动翻译。
Quickly on that question, a subway is not point-to-point transport. It still requires a train station. So I think from my perspective, just answering that question, you can't compare a subway to a vertical takeoff and landing aircraft.
And maybe also to, let's say, Diamond volocopter, as we now have an answer already of two of our panelists. What do you think? Do you think our volocopter in the beginning still will be a competitive tool for point-to-point transportation inside cities, or will it more likely be used in other purposes?
It doesn't. We don't see as a competitor to the existing infrastructure or future infrastructure of cities. So we see the eVTOL market will be an add-on, because in the dense area, the population is so high, so you will need the high-speed rail transport, and you will need subways, and you will need buses, and you will need all this infrastructure. But you also have to utilize the third dimension. And if you can't utilize the airspace above you, because of the high population, it will always be a jam, a delay. So therefore, especially in those cases where you want to have less delays and just innovate and give your city more capabilities for transportation, and mobility means speed. So that means every economy wants to have more speed. So then you have to utilize the airspace. And this, you have very, very good opportunities, because you can separate lateral, we can separate horizontal. So this gives you many, many opportunities to just transport more people at the same time, even if you have to railway there and the subway. So that's just an add-on, but it will speed up your economy.
Okay, thank you very much. And I think I saw some people are already getting a bit tired, so we'll give you another 5 minutes coffee break. We have one more question, and then we going for a short break in front of the next session.
Thanks, Willie. Josh Portlock from Electro Aero Portable Charging Solutions, and my associate Isabel is going to translate as well. Quick one about standards for charging. So we've been pushing the SA International Charging Standard, which is based on the Chinese GBT coupler, for over 6 years now, and had pretty good adoption, but there are still some stubborn people sticking with CCS1 and CCS2. So what's ever airframers' thoughts on that, given the fast pace of Chinese electrification? And do you think we can convince the Americans and Europeans to just concede defeat and adopt the Chinese standard?
Maybe Michael and David, or would be.
I think that it needs to be standardized. It doesn't make sense to have various different chargers for different aircraft. So my view is that there needs to be consolidation. For me, it's less important, I think, for infrastructure hubs at airports and things like that. It's way more important. I'm going to be avoiding that with my machine. We're more direct from your home to another hotel or restaurant, something like that. So it's slightly less of an issue for me, but I'm sure some others have other.
Yeah, I think there would be the question, like for the EDA 40 and for the volocopter, saying at what standard are you looking for? Say, will be the same. Actually, first it will be the same standard for volocopter and diamond aircraft, and which of the two standards which were mentioned right now you're going to use?
Dr.
You please.
Okay. So for a volocopter, so we have different solutions. So for us, charging is an option because we swap the battery. When it comes to the charging solution, so that means to the connector, that's just a small detail. So this we see there will be several options. However, I agree what he said. So I definitely see we have to standardize. So I would appreciate a lot if the Chinese system can be used also in Europe and also in the US, and if there is a standardized infrastructure. From the vehicle wise, for us it's no problem. We can just make another option. It's just a minor change if we change the connector. And we can go ahead with multiple ones, and then depending in which region the aircraft will be delivered and will operate. So there also the customer will get the required standard charging port, and that's for both. So for EDA 40 as well as for for volocopter. However, many customers are asking for a turnkey solution, so that implement the charger as well as the aircraft itself, as well as some other ground handling equipment. So if we deliver this as a package, we also want to consider, of course, and consolidate within standardization organizations like EuroCA, EuroK, so where we talk with the other OEMs on the market, also Chinese ones, to standardize the charging solutions for everybody.
Okay, thank you very much. Let's see, there is one question over there. Okay.
Yeah, thank you.
Scott.
Reply also to the charging standards. One of the wonderful things about MOSAIC is it doesn't require ASTM standards. You can use any standard. It could be SAE or any other standards that are around the planet. So as long as there's an equivalency that assures the safety, it's an open book. A person or a manufacturer could create their own standard for that fact. So it's very flexible, the system. So that was just a comment there. Then for David and Michael, David Gu, I think it'll be clear that your pilot certification will be ultralight. So there will be flight training, I'm sure, required, but no pilot certification. But then I'm curious about Michael and David on your products in terms of pilot certification. Are you looking at sport pilot or distributed, or rather powered lift, which is yet to be completely defined, I think, or what airman certification are you driving toward or expect?
Sure. So as you say, it's still a little bit up in the air, but what we're planning around is essentially differences training and then type rating. So whether you've got a PPL or a sport pilot's license, you'd then do a conversion course with differences training to type. So then it would probably be a powered lift rating on your PPL. That's the way I see it going. It seems the most sensible route. I think each individual type will have, like you do with a helicopter, so you have to get a type rating on a R22, an R44, or a 505. Each aircraft has its own operating procedures and operating manual, so it would be no different to that, in my opinion.
So, David, so how would it be with the volocopter, for example, if you have the Volo City and you have the Volo X? One would fly in the ultralight class, the other one in the certified class. Would there be two totally different certificates, or would there be try to have a certificate which could fit both, because the aircraft will be pretty similar, I suppose?
Yeah, so if you're talking about eVTOL aircraft, so in basic category, we are looking at PPA plus type rating, as also was already said, with a minimum requirement for hours, so that will be more than the initial PPL, because there at the moment we are at 40 to 45 hours. So we are looking 60 plus up to 80 hours as a minimum, and then comes the type rating on top. The type rating we try to standardize on our simulators. So we run FMPT2 certification of our simulators. So that means we are looking for that most parts of the type rating can be done outside of the aircraft, and then only a minimum emergency procedure training has to be done inside the aircraft. So that's for the Volo City. So for the ultralight category, it will be less from the pilot license, because most of the ultralight passionate pilots, they don't have a private pilot license, they just have an ultralight license, and there just will be a difference training.
Okay, thank you very much, and we have to close here as we have to look forward for the next panel. So because we are already 5 minutes over and we are on a good pace. So maybe you can ask the questions to the panelists directly after at the cafe pause, which we'll have for some minutes now. Thank you very much. Thank you, David.
Thanks for the opportunity. Thank you, Jim. Bye-bye.
Thank you.
Thank you. 好，很多问题啊，大家问得非常好。
Lots of questions, fine discussion. Now we'll proceed with the forum. We don't have time for the tea break, for any break at all. So if you need coffee and any snacks, please go outside and fetch yourself. Subject 3 is about the update and the perspective of electric fixed-wing airplane. Let's invite the first presenter from Liaoning General Aviation Academy President, Vice President Fan Xiangyue. Topic is reflections about electric aviation. Let's welcome. Ladies and gentlemen, good afternoon. It is my honor to share with you. I want to share with you about opportunities, challenges, and thinking about the e-flight. Now we're in a historic milestone. Aviation is going through the deep transformation, climate change, energy crisis, and tech improvement are jointly promoting the rise of the e-flight. But it also faces the challenges from the technology, the rule of law, and the market. So I want to share with you in terms of opportunity, status quo, and challenge. In recent years, the e-flight has been prosperous in development. The main cause was due to the following. To start with, the urgent requirements about environmental protection, energy transition. The e-flight, due to the zero emission and the low noise, it has become the key pathway for dual carbon goals. The reason too is that in the policy promotion, the Chinese government realized LAE as an important tool for the new quality productive forces. It issues a series of policies and to further promote the development. For LAE, it has the large radiation and a long supply chain and a high growth rate and high leading perspective. At the same time, the industrial structure is quite rich, including the low altitude manufacturing, the flight activities, and the flight guarantee and comprehensive services. For the low altitude economy, the features of it means that LAE has wide market potential. Therefore, in order to promote the LAE, China has issued a series of policies. The ministries and departments of China based on LAE, the aviation equipment, in the future 5 to 10 years, and namely the 15th or 16th five-year plan for the aviation equipment planning and also the development pathway, and there are some guiding opinions. The third part is, in the past more than 10 years, and for the EV development has been fast. So there has been good industrial basis for e-flight. It's mainly illustrated in the following aspects. To start with, in technology. For the EV, the three technologies, namely battery, the motor, and the e-control, including some general technologies, can be transferred and repeated and in the aviation. In terms of industrial chain, and for the EV, industrial chain, auxiliary equipment, and infrastructure can be used by the e-flight. In terms of standards, and for the EV, and the standards can be used as a reference for e-flight. The fourth part is about the higher needs about commercial application. Globally, the e-flight market is growing significantly. The compound annual growth rate more than 20% by the end of 2035. The market scale will exceed more than 100 billion RMB. About the development status of e-flight at home and abroad. Talking about e-flight, currently we need to think about the eVTOL class, and now the eVTOL companies amount to more than 400, including Joby, Archer, some leading giants enterprises. including some traditional, including the volocopter, etc., and Boeing and Airbus, including some the automobile, internet enterprises. Joby Ultra leading in the way in terms of eVTOL. For the Joby eVTOL, it is the 5-seater manned eVTOL. In 2023, it realized the first manned flight. In 2024, and March, FAA for this eVTOL issued the special conditions. That is the first special condition issued by FAA. But the special condition from the initial recommendation draft until the official release took some 1.5 years. So in the process of formulation of conditions, we face some difficulties and challenges.
The Archer flight again is a 5-seater eVTOL in 2024. Soon after the special conditions were released for Joby, Archer also got approved, and their aircraft is planned to launch for commercial operations at the 2028 Los Angeles Olympics. Other than whole aircraft R&D, many companies focus on the specific parts. For instance, Magni-Nax in the States focus on developing electric propulsion system, which has been used by several aviation companies. FAA also launched special conditions for magnets for that. Now let's move on to the domestic landscape. And we see that eVTOL now is developing rapidly, and so far 2 eVTOLs got the TC permits. One is the EH216-S, and that's the first fully certified eVTOL. In 2023 October, it got the TC, and in December it got the AC, and in April last year it got its PC. So it's quite fast, and that shows the accountability and the responsibility of CAAC. Next is the 2000 CG, and it got the TC in 2023 and a TC in 2024, and it's the maximum takeoff weight is 2 tons. So in fixed wing eVTOL, we have also seen lots of progress. For instance, Liaoning General Aviation Research Institute was established in 2011, and since then we've been working on e-flight R&D after 10+ years of effort. So far, we have established a RX series aircraft line, RX-1E. It's the first 2-seater electric aircraft. In 2015, it got the TC from CAAC. This is also the world's first 2-seater electric aircraft to receive airworthiness certificate. Based on that, we also developed RX-1E-A. It's a extended range version of RX-1E. We have also refined the battery, and so far RX-1E-A could have a endurance of 2 hours and maximum range 200 kilometers. We also have RX-1ES. It's a 2-seater electric seaplane that can take off and land on water. In 2021, it obtained its type certificate. We also have RX-4E. It's a 4-seater electric aircraft. And TC took quite a long time, about 5 years, and eventually got its TC in 2024. And so far, RX-4E is the only normal category airworthy electric aircraft. We also have RX-4M. It's a 4-seater lithium battery-fueled hybrid prototype. So far, it has completed its maiden flight. Other than those I've mentioned, we also have RX-1E-E. the model that's suitable to fly in icy and snowy environment. It can take off on the icy surface. Also, other than the two four-seaters I mentioned, we are still working on RX-4ES and RX-4HE, a four-seater hydrogen-powered aircraft. And it directly uses hydrogen as a fuel. So as you can see, we are following the direction of dual electricity and hydrogen-powered aircraft. We also have the RX-1H electric helicopter. So over the years, we have achieved quite a lot, from single energy to multiple energy sources, from conventional takeoff and landing to vertical, from single power to distributed power. We have established a comprehensive platform, and we believe the industry will see faster and more comprehensive development moving forward. Now let's move on to the challenges and breakthrough path. Well, electric vehicle or electric automobile development has set a good foundation for us to develop eVTOL, but still we're facing lots of technical challenges. For instance, the battery intensity, lithium battery intensity. Although intensity now can reach 300 watt-hour per kg, but it's still not good enough. Also, the security, the safety of these batteries is also a big challenge. High intensity and high safety are two somewhat contradictory features, but we need to make sure both work well. Another challenge is the law and regulation challenges. Though we have got TC for many aircraft, but in many cases, the review is based on special conditions, or the permit is given on special conditions. We hope we could set up unified standards and practical guidelines as to save time and efforts required to get the TC. Thing is about the insufficient airspace availability. Well, now we have some low-altitude economic demonstration zone, but still not enough zones have been assigned, and we hope we could have more such zones for testing and for applications. Also, we face some funding challenges. We see some foreign companies went bankruptcy because of short of funding, and we need to make sure that companies are incentivized to pursue new energy aviation innovations, while at the same time governments need to provide supportive policies. So the entire supply chain of eVTOL, of e-flight, is very high, and we need to further improve the entire system to ensure better protection and guarantee. So electric aviation represents not just innovation, but also a solemn commitment to sustainable development. And we believe that the dream of a green sky will become reality through a synergy of policy, talent development, technology, and the market. Let's join hands to write a new chapter for the industry.
On the update of this aircraft, which you all know is the first certified electric aircraft worldwide. And we had it flying in Germany this year. And now I move to another aircraft which is exactly in the same class. It's the Smart Flyer from Switzerland. So you see we have more countries than ever. And Rolf, please tell us about the Smart Flyer, which is a little bit different configuration, but also 4 seats.
So, thank you very much for your interest, for inviting me. It's the first time that I'm here at this e-flight forum. So I would like to take the opportunity to introduce myself. I'm more from the operational side. I started to fly helicopters in the Swiss Air Force, flew their helicopters, Super Puma Cougar, for 32 years. And at the same time, I worked for Swiss International Airline. I stopped there 3 years ago as a captain on Airbus 330 and 340. And yeah, about 10 years ago, we started the project Smart Flyer. As Willi told, it's a 4-seat aircraft, this time at the Paris Air Show. And it's more or less an aircraft for flight training. But I have a movie, and in this movie, you can see what it is.
Have you ever dreamt of an aircraft that is as quiet as a glider, so efficient that it hardly needs any fuel? An aircraft specially built for the needs of modern professional pilot training? This does not have to remain a dream. Introducing the Smart Flyer SF1. The SF1 is a hybrid electric 4-seater training aircraft. In military aviation, cadets train on aircraft engineered from day one as trainers. In civilian aviation, pilot training often relies on repurposed sport and leisure aircraft. SF1 closes that gap, a purpose-built professional trainer for today's syllabus and tomorrow's standards. The SF1's efficiency starts with its propulsion architecture. The propeller is mounted aft at the vertical tail in a tractor configuration, drawing undisturbed airflow. This setup targets approximately 25% higher propulsive efficiency compared to a conventional nose-mounted tractor layout. More training minutes per kilowatt hour, less noise, and smoother handling in the circuit. At the heart of the platform is a modular nose. Choose the E-nose for fully electric missions or the hybrid nose for extended range. We always fly with the most efficient module for the task at hand. Endurance electric, up to 2 hours. Endurance hybrid, up to 4 hours, with approximately 50% less fuel burn. Mission flexibility without compromising training quality. Maintenance is just as modular. Because the power unit is serviced separately from the airframe, simply swap the nose. Aircraft airtime increases while downtime drops. That means lower operating costs and less pressure to maintain oversized fleets to meet your schedule. Add the training essentials. Very low noise for community acceptance, 4 seats for instructor, students and observers, dependable turnarounds, and a cockpit philosophy built for professional instruction. This is a platform designed to keep students flying, instructors teaching, and operations on time. Smart Flyer SF1, the dedicated trainer civilian aviation has been waiting for.
So I would like to talk a little bit more about the aircraft, why it's built like this. So it's a 4-seater. The range with a hybrid system is around 800 kilometers. And it's not the fastest one, but it's an average speed of 120 knots. And most importantly, it's built with this big slow turning propeller on the vertical tail. That means this one is very silent, and it's important for the environment, but as well for the instructor and the student pilots, and the passengers as general. The most important thing is the direct operating costs, which are about 50% of existing comparable aircraft. Why is the propeller on the vertical tail? This is only feasible because of the lightweight of an electric motor. An electric motor is about 5 times lighter than a combustion engine. That means the designer has a completely new way where to produce the thrust. You all know this configuration with the propeller in the nose. The air masses which are accelerated are just hitting the biggest fuselage cross-section and breaking or are braked down. When you have the propeller on the vertical tail, there is almost nothing, no structure which breaks the accelerated air. And this is not just theory, it's already tested with University of Stuttgart, with the e-Genius. They say it's about 30% more efficient. We say, okay, 25% is fine as well for us. 25% increase the efficiency due to the installation of the propeller on the vertical tail. On the vertical tail electric motor, we use the MRAX 348 for the prototype. And it has 160 kilowatt takeoff power for 2 minutes maximum. And in the wing are the batteries, which are fixed installed. We have now H55 batteries, a Swiss battery manufacturer from Andre Borschberg, a spin-off of Solar Impulse. And in the nose section, we have for the prototype the range extender, which consists out of a Rotax 914 with a YASA generator. The nice thing about this configuration is not only the efficiency gain, it's as well the advantage that the nose section is free for any kind of energy module. I told you the prototype has the range extender with the ability to fly about 800 kilometers, but we can as well change that energy module to batteries, additional batteries. And the nice thing is that every student pilot should be able to swap these two energy modules and to choose the energy module which suits best the mission. That means flying around the airport will be battery electric, all the shorter flights, battery electric, completely emission-free, or for longer flights, navigation flights, and so on. The student pilot chooses the range extender. But this is not the end. We could as well imagine to install a fuel cell, depending on the availability of hydrogen on the airports. So the big advantage is less maintenance, I already told. A conventional today's aircraft needs to go to maintenance shop every 50 or at least every 100 hours. An electric motor is much maintenance friendlier. That means the intervals will be higher, and as the nose section is independent of the rest of the aircraft, you could, for example, as a flight school, have 4 aircraft with different energy modules. So your airframe is always available for training, while, for example, the one battery is on ground for charging, the other one is installed in the aircraft, or the range extender is in maintenance shop, because this is the part which needs the most maintenance. So you can reduce the number of aircraft, increase the availability, and save costs. This is our small team. We are quite a small team. It changed for sure during the last 10 years, because in the beginning of a project you need different professionals. And right now we are in the final installation and testing of the prototype. You need other experts. This is our time scale or our time frame. We are now installing the batteries next spring from age 55 and preparing the flight testing phase. In summer 26 should be ready for the ground testing, and we plan now September 26 for maiden flight. In the same period, we are searching for industrial partnerships worldwide, because for the next step, the certification and serial production, we need a partner in order to facilitate or to speed up the process for certification. Type certification is planned for EASA CS23 or FAR 23 or maybe the Chinese CAAC 23. That's everything from me. If you want to take pictures of my contacts, I unfortunately don't have a QR code, but you can write to me. And thank you very much for your interest, and I will be available for questions, I think, in the panel discussion.
好，感谢来自瑞士 Smart
Thank you, Mr. Rolf Staber from Smart Flyer for your presentation. It is a really good one about the configuration for the airplane, about the pathway, a very clear demonstration. Our next speaker is Vice President Liu Fangguo from the United Aircraft Group, and the topic is new opportunities in low-altitude economy, UAV innovation driving China's industrial upgrading. Let's welcome Mr. Liu. Good afternoon, I'm Liu Fangguo from United Aircraft. I want to share with you about United Aircraft in terms of the LAE, what we have done, what the progress will be made. We also want to report to you about some of the understanding of UAE in practice, LAE in practice. For LAE, my understanding is mainly based on the three elements. The first one is building the aircraft and also infrastructure and application. So I want to share with you based on the three elements. To start with introduction about United Aircraft, we have three phases of development. The first one is initial accumulation, namely the flight control technology accumulation. In the second phase, is about the helicopter, 10 years of development. It is the shared shaft, the drone, and application, and in terms of past decade, we've made some achievements. The third phase is about LAE progress since 2020 to the recent years, and we've been issuing some products, and including some electric drones, and also the crop protection, 1.4 tons, and this year's newly issued product, the unmanned helicopter, and also the 6 tons unmanned aircraft with more than multiple years of development, and we have 2 headquarters in Beijing and Shenzhen. Industrial bases, the first one in Harbin, the second in Wuhu. We also have the R&D center, including Xi'an, Chengdu, and Singapore, and also the demonstration scenarios in Dongtai, Shiyan, and Beihai. We already have the spectrum of products in the company, so we can see that in Harbin and Wuhu is mainly focused on unmanned helicopter in Shenzhen. Because in electric and multi-rotor, the industrial chain is quite advanced, and so that in Shenzhen we mainly have deployment in electric development. In Xi'an and Chengdu, we mainly focus on flight control and also the turbo motor, etc. For Singapore, it is the AI R&D center. 3 elements for our AE. The first element is about building the aircraft. For the unmanned aircraft, we have a classification. In the past 10 years, since 2013, with the founding of the famous drone company, whose name is DJI, and till now we already have some 100 billion scale. In recent years, we have industrial drones developing very fast. For this part of the market, will be like 10 times of consumption market. This part is mainly for the multi-rotor and crop protection industry application and fixed wing, composite wing, and aviation, general aviation, mainly for the manned passenger aircraft. We categorize into the following parts. Talk about the aero car. It came from the UK with 4 propellers and the car. It became the aero car. That was the simplest version of the aero car. In 2017, we had one expert on multiple rotors, and they have one automobile plus 4 rotors, and they proposed the idea of the aero car. So based on the short range, medium range, and long range, we can categorize the aviation grade UAVs. On our products, we mainly resolve our mission above 100 kilometers. Now we have the turbo shaft powered system. As for the future development plan, we also have the hybrid and new energy. We are taking it into consideration. That is about the categorization for the products. For the development of the product, we have the diversified products. To start with the electric multi-rotor for the grade inspection, and also the TD550, the drones. There it is called the coaxial unmanned UAV. And we also have other types of vehicles and aircrafts with multiple functions. And R6000 mainly for the cargo aircraft. At the same time, we have the manned aircraft. That is the direction for development in the future. Capacity coverage, we'll skip it about the specifications of the products. For Q20, up till now, is mainly for the grade inspection and also the agricultural monitoring. Compared with Q1 and the T140, that's the 3 masterclass and for the agricultural development. And we also have the spraying and the fertilizer application for the fruits and orchards using the UAV, the TD550, and also the TD220. It is the unmanned helicopter. It is a T-series UAV. We mentioned about coaxial UAV, and we started from coaxial technology. It is the more the special technology. The first TC, T1400. In June, in the UAV conference, we issued a product with the takeoff weight 1.4 tons. The payload 650 kg. For hydrogen, to the air show and up till now, more than 1 year of development, we made some breakthrough in technology, notable achievements. R6000, we also got the special flight license. We are also working on the 5th generation, the turbo shaft for civil use. The turbo shaft motor is mainly for military in China. In the future, we hope to use it in R6000. Infrastructure. Infrastructure is about the new type of infrastructure. We have the 5-3-1 structure. In the 13th five-year plan, there is the GA, General Aviation Economy. The target is 5,000 airplanes, 500 airports, but up till now, we can see that according to statistics, for drones and UAVs and GA, the total number is more than 100,000 in the market.
And this is the new concept, one brain plus other infrastructure surrounding it. That's also a new feature of UAE. Sorry, LA. 5 different types of takeoff and landing points. So focus are the following: the residence area, the building entry, community entry, and etc. We see eVTOLs now can enter into the community and into the residential buildings. We can also build the takeoff and landing pads on top of residence buildings. These are under development in Shenzhen and also in Guangzhou. 1,000 plus takeoff and landing pads have been designated. eVTOLs be able to enter residential buildings, office buildings, communities. These are the control measures. And in terms of infrastructure, this will cover telecommunications, monitoring, low altitude countermeasures, as well as radar and etc. In terms of monitoring, we will use radar and etc. to detect intrusion and prevent unauthorized flight. This is about the brain. Or the so-called whole space unmanned system. We have built an algorithm platform relying on low-altitude digital twin technologies. And so far, this platform is well used. In Dongtai and in other areas, this platform has been employed. Eventually, this platform will be backed and managed by the government because this is security related. Also, calculation and computing power are critical. In terms of infrastructure, this would involve low-altitude digital twin, city CIM, airspace grid management, cloud map, Google Map, and etc. So we will develop an airspace map on top of those technologies and network data. So we will need strong computing power to support development of the brain. We also have 4 layers of development within the brain. So include the first layer is the time and space layer. Second is the management of fleet. Third is management of business, and fourth is management of end users. In terms of applications, we have also carried out lots of attempts and explorations, basically focusing on these following aspects: emergency firefighting, agriculture, energy, and SM. In emergency communications, we have delivered quite a few applications already. We delivered our application to Grade A Response Authority. We help them build a telecommunication task. We also use the TT550 to help them to build their rescue network, allowing end-to-end telecommunications. These two aircrafts, one for firefighting, the other for forest firefighting, one for urban, one for forest, in Suzhou, Dongtai, Zhuhai, Taizhou, and Jilin. We have already tried out real case applications, and in terms of urban firefighting, our technology is quite matured. We have made quite a few breakthroughs in this area. For transportation deployment, these are the three typical aircrafts from 5 kg to 500 kg, the three musketeers. For agriculture, we have T1400. This is a heavy lift unmanned helicopter, and this maximum payload is 500 kg. This is a manned fixed wing helicopter. This is a unmanned heavyweight helicopter. So energy, I've already talked about this, so I'll skip this one. Thank you.
Hello, thank you very much for this nice view of another point of view in the low altitude economy. As you see, there are endless opportunities here. Now our next guest, Karl Kaiser from Germany. He will give us an update of a program we briefly heard last year, which is an electric commuter aircraft, where many people are persuaded that the first use of electric aircraft in a larger scale could be electric commuter aircraft, and you will hear more about this later today. Stage is yours.
Okay. Good afternoon, ladies and gentlemen. My name is Karl Kaiser, and I'm happy to be here today to present you the electric regional air mobility solution, eVTOL, MDA-1 eVTOL. Thank you very much to the Chinese Association of Aeronautics and Astronautics, and to Willi and Flying Pages for the opportunity to presenting our project here. And one more thing, other than in the announcement of this presentation, I'm not only consultant and consultant to this project, I'm also one of the founders, investor, and the CTO of this project. Thank you.
Imagine a new era of flying. Imagine state-of-the-art engineering propelled by electricity. Efficient and certifiable under today's standards. Imagine regional travel on board an all-electric aircraft. Introducing MDA-1 eVTOL, a clean slate design developed for electric propulsion. Our outcome of over 30 years of aviation experience. Swappable power banks, exchanged in minutes, deliver the promise of sustainable electric flight and drive up value for operators both in the present and future. The cabin quickly adapts to a wide range of purposes, making it a truly versatile aircraft, fulfilling every need. Within existing rules of the air, MDA-1 operates just like a conventional aircraft, connecting remote destinations and busy hubs alike, including your underutilized local runway. It's the first generation of the MD aircraft family that brings our vision of zero-emission flight to life. Soon, there will be no need to imagine any longer. For many, the sky is the limit. For us, it is just the beginning.
Okay, let me start Let me start with the description of the problem and the starting point. What we see today is an increasing demand for regional air mobility. This is not only the idea of Karl Käser or MD aircraft, this is also a true fact that has been investigated by international consultancy companies like Roland Berger or McKinsey. At the same time, the operators are facing aging fleets and the aircraft are of old design. As a third fact, there is the drive for carbon neutrality from governmental side as well as from public side. So as soon as the operation of the carbon-free operation becomes cheaper than the carbon-emitting operation, this thing will take off. The solution to the problem is the MDA-1 eVTOL. This aircraft is tailored for the needs of the operators. It has efficient aerodynamics and a lightweight composite structure. It is of rugged design and for short takeoff operations. This is what the operators request. Unfortunately, this is a little bit disappointing to aircraft designers because they don't request sleek lines and they don't request retractable landing gear or other fancy stuff. They also request operation of only 200 to 400 kilometers per mission, which we can match. The payload is 918 kilograms, and please remember, we don't need any payload for fuel. It is also designed for single pilot operation. And the swappable battery bay allows exchange of batteries and replacement of the batteries by other power solutions like hybrid system or hydrogen system. The design is the result of 13 years of cooperation and experience of the companies MND Flugzeugbau and Casero. Here you see our staff. Because this is already an existing company with more than 140 employees in place. And we have considerable advantages over other startups. This is not a startup, this is a scale-up. Our founders are all experienced in their field of profession, aviators and electric aircraft designers. Here you can see some of the past experience that the people in our program have. We are working on electric aircraft since the early 2010s and have been contributing to projects like Solar Flight, Sunseeker Duo, or eVTOL Alice. The company MND Flugzeugbau has one of the few certified electric aircraft in delivery, with more than 150 aircraft of the Motorglider JS3 race delivered. Here you can see the timeline. For your orientation, I have drawn the red line. The the aircraft design is completed, and we are now in the detailed design phase. The production has just started. So, and here at the end of the presentation, No, I'm not sorry. I'm not on the end of the presentation. Sorry. I have to show that our concept is valued by our potential customers. Yeah, we have up to 40. We have 40 pre-orders from European operators like OFD, AirN, or Inselflieger, and we have 70 more pre-orders from the United States. This shows the potential and the trust the operators have in our project. Our investors also show the trust in our project. The main investors up to date have been the founders. The conceptual design and the aircraft design have completely funded by the founders. Supported was this by a research grant of the Federal Ministry of Economic Affairs and Energy. New investors to the project are several private investors, the German investment bank of the federal state of Lower Saxony, and the Piper Deutschland AG. The Piper Deutschland AG is the German representative of the Piper Aircraft Incorporated, and we are very happy that they trust in us, and I think it's a great statement. On top of being the representative of Piper Aircraft Incorporated, Piper Deutschland AG is one of the biggest MRO companies all over Europe. So finally, now I'm at the end. These are the first pictures of the production that has been started. Just last week, the first plugs for the holes come out of the workshop. So thank you very much. I'm at the end of this presentation. If you have any questions, feel free to find me here during this event, or visit our website www.mdaircraft.com.
Thank you, Mr. Kase, for your speech. You're an old friend. Last time you came here to introduce to us about your aircraft project. The next speaker is from China Aircraft Strength Research Institute Chief Engineer, Deputy Chief Engineer Wu Jintao. The topic is on the eVTOL, key strength issues in eVTOL development. Let's welcome. Distinguished leaders, guests, and experts, I want to share with you about the strength on the eVTOL. What are the challenges we're facing right now? The agenda of my speech, to start with, is under the strong support of the national government and ministries and the CAAC, and the LAE, including the UAV, eVTOL industry, has been developing at a fast pace in terms of market scale, the financing, funding, the certification, and the planned certification. We are going into the fast track. In terms of technological pathway, up till now for eVTOL, we have this common ground, namely the tilt, the rotor, the fixed wing, and composite, etc. Mainly from energy, it is the hybrid and the pure electric and other sources of energy. Based on the market needs, we may have some different definitions. Up till now, requirement from regulators are clarified, mainly from safety, including the comfortability, economical and environmental protection, etc. As a basis of success and reliability and safety is fundamental. That is why in 2022, when President Xi Jinping met the C919 team, he instructed that the safety and reliability should be the priority for development. for the emergency, and in particular for LAE or for the UAV industry, the impact will be huge. For instance, we already have some special issue and special conditions due to communication cutoff and of normal power, etc. Zero-sum accidents at home and abroad. The certification we need to gradually improve. At the same time, from the market in particular, the user mental can have some change of mind to pay more attention to safety. The second part is about our thinking on strength. In terms of the aircraft design, the payload is the first. Now for the LAE, we have the ground payload, aerodynamic and commercial environmental payload, and they're just compounding with each other. Mentioned by Mr. Tian and Mr. Guo, for eVTOL aircraft, it may face some environmental and operation scenarios that are richer than the traditional GA. For the comprehensive structure guideline is the gold standard for traditional airplane. It is about the design, about the rigidity and durability, etc. It is the overall overview for all these features, and a full-scale prototype is one important part in terms of the test. For the strength, the historical mission is that we make the flight safer and more efficient. When we encounter the birds fleet and the hail, we can still maintain a flight without crashing. When there is some special damage requiring forced landing for some special terrains, we can just land safely to ensure that there is no casualty. For eVTOL, lightweight and long user shelf life, including the comfortability, the noise, vibration, we are proposing new requirements. As a result, for the current industry, and we are thinking that for the eVTOL flight design and operation, we may have some different standards compared with traditional GA. In a traditional domain, we have a lot of standards and requirements, but for eVTOL, for manufacturers and for industries, we have our own special standards for airworthiness that is have the basic alignment. In terms of verification standards, that is not unified yet. O&M support, there is a shortage of basic infrastructure, for instance, fast inspection, key technologies, etc. In terms of design, the current strength design standards cannot fully cover and accurately and compatible with eVTOL, the new kind of aircraft. Just one example for the low cost and the compound material design. We talked to a lot of investors, and they propose that the current materials and for the large aircraft, we use the thicker panel. But now we propose that for the compound materials, the thin panel and deformation, how can we make a judgment? How can we resolve the issue? In terms of verification and standards, it is the same issue. For now, the standards are following airworthiness for the large aircraft, the whole process and logic. For low altitude aircraft, they cannot fully cover the scenarios. What's more, the cycle is long. As a result, it can be a major difficulty for the industry. For instance, in the environment and for aircraft, there are the frost, the hail, the rainfall, and we can fly as usual. But for eVTOL, can it cope with all kinds of weather conditions, including we just mentioned, if there is automobile, we make it into the aero car. By the same token, in all kinds of weather patterns, they can move. But for aircraft, how can we describe the definition of all kinds of scenarios and of reliable flight? How to make a definition? That is one challenge. Here are some facilities in the US, and for instance, high temperature and there's the sunshine, the hail and the frost, the rainfall, and we have the experimental facilities. For the Strength Institute, we built the world's largest weather test center. For O&M, we don't have relevant means. For the health management and guarantee system, is not comprehensive enough. For the health monitoring, is it possible that for the eVTOL, after the flight, in such a time period, we can realize we just promote it into one workshop to have the fast inspection to find out the issues and to have the fast repair, including the repair intervals and how can we make a decision. That is one issue we're facing. And also there is some infrastructure in the industry, there is a shortage. That is about repair and fixing and inspection. The third part I want to share with you about the eVTOL airworthiness and some of the practices and technological breakthrough. We know that takeoff and landing for the airplane, that is the black time is impacting its safety. For eVTOL and the vertical landing and takeoff, that is one important session. There are 5 steps, as mentioned by previous speakers: vertical takeoff, conversion, flight. Then there is the vertical hovering, conversion, and the landing. In all these steps, and we can amplify the time for takeoff and landing. For instance, the wind resistance in this process, in the emergency, how can we ensure the safety? That is a major challenge. Emergency landing with the out of field and also the failure for the engines in the severe weather conditions. Can we have special landing process? For normal landing, we have the landing gear and also the brake and the engine by the energy absorption and to lower the momentum to ensure the safety. But for the crashing landing based on the structure deformation and by certain damage in the structure participating in the momentum consumption and to ensure that there is no casualty during the landing. For the compatibility, it means that for the crashing landing, we need to ensure the passenger safety. In airworthiness regulation about the structure and the system, about the emergency devices, the fire protection, the fuel system, there are 37 items of airworthiness regulations and 9 advisory channels, including relevant contents. I think you're more familiar than me about that. I don't want to elaborate, and based on the development of the commercial aircraft, the crash worthiness research started from the 1940s and 1950s and gradually promoted, and now it becomes mature. The crash worthiness mainly need to solve 3 parts of the question. For instance, if there is the crash landing, can the structure use as a buffer to protect the important cargo and the passengers within limited time, whether the people can exit the aircraft. For the aircraft, and we build multiple layers of systems for testing capacity. Experiment and analysis are also integrated in this process. For the airworthiness requirement, since 2019, July, EASA issued the 01 regulation. The 2022 CAAC issued the EHang special clauses and provisions. In November, based on auto flight and some of the new standards on the core system, reliability and flight control system, energy storage and management, artificial causes, and we have updated some requirements. For the crash worthiness can be the result of the following causes. For instance, multiple configurations and a powerless crash, because for the eVTOL, there is no enough space or the payload as used as a buffer. What's more, the aircraft and in the crashing environment can be more complicated. Energy system can be a limitation. When there is a crashing, the thermal runaway, the went into fire of the battery can bring about major risks. Because of the limited space in the eVTOL, therefore protection of the passenger and the absorption of energy and exit, there are stricter requirements. About the absorption and also the dissipation of the energy and during crashing and to ensure the safety of the crew. Verification, physical experiment is the basic means, and the LASA has some crash testing and the shell pong. There are some the battery pack and the drop experiment. So the condition of the experiment and what is the speed of drop, and how can we ensure that whether the speed is in line with the requirement, including the methodology for the experiment and the data testing, analysis, and the tiering and the rating standards. About the value analysis, that is one important support for some of the experiment as the sources of data. Combining the data from experimental analysis, how can we simulate the feature of the materials and multi-physical coupling and the failure model and into all this process. And by simulation, one important thing is about ensure the limit of safety. That is the core issue. Namely, the fuselage and energy storage facilities, what is the standards for safety design. For the passenger safety design development, how to make the relevant formulations of rules, and how to ensure the platform is safe, and how can we ensure the internal systems are safe, and environmental safety, how can we ensure that, and the passenger safety to be combined to ensure the crew safety.
So this is the construction of the eVTOL crashworthiness technology system, from general requirements to specific requirements to testing methods and tools and to capacity verifications, as well as the physical experiment verification capabilities. We should make maximum use of our institute as a national key lab of strength and structural integrity. And we carry out research from 5 perspectives: computational simulation of complex mechanical behavior, fatigue and reliability of structural systems. Mr. Tian and Mr. Guo earlier mentioned same thing about whether or not we need to consider fatigue and reliability and how to approach these issues. Well, we believe further work needs to be done. The third is equipment dynamics and noise control. Noise is quite important, and Joby ranked noise number 2, security number 1. Fourth is combat damage and structural impact resistance. How to ensure crew safety when there is emergency landing or crashover. And the fifth is rigorous environmental intensity and adaptability. How would our aircraft perform in extreme weathers? And can it still perform as it's designed to be? So, as the national key lab, we hope we could provide due support to R&D across China. We also have Open Fund, National Key Fund, and Aviation Fund, as well as Joint Fund, Aviation, Large Aircraft, and the e-Aviation Fund. We hope to work with industry peers to solve the bottlenecks and challenges together. That's all from me. Thank you.
Thank you very much. So we see safety is very important for this new type of technology. As we are in the fixed wing session now, for the end of the day, we have some very nice thing which you can look at, and you can look at it like a little bit of holiday, because flying with a seaplane was always a dream for many people. In the beginning of last century, it was very common. Then it's not that common anymore, unless in certain parts of the area. But now, with electric aviation coming up, suddenly there are no new use cases which could be very interesting and could be used, which could not be used with other aircraft, with combustion engine aircraft before. So, Eric Litun from the company Elfly, please give us an update on your seaplane.
Thank you. Hello, can you hear me?
Yes.
Yes, good. Ni hao. My name is Eric. I am honored to be here. It's the 3rd time I'm here.
and I'm going to tell you about Noemi, which is the seaplane we're building. I sent a video. I don't know if we can play that first, or did you put that last? Will it come if I push?
So it's super exciting that we're right now doing testing on this level and can sort of see already that we are very close to an extremely good solution.
Yes, that was a short video from first flight of the subscale we had this summer. But I'm going to give you some background for my company, and I'm here with my CTO. If you can raise your hand, Thomas. Stand up. So this is Thomas Bröderskift. He designed this plane. He is one of the first people to make an electric seaplane in the world, and this is a very interesting project, a two-seater hybrid, fully electric, and had first flight in 2018. After that, we built a conversion of a race plane. This is built for high-speed racing, and it's a conversion where we had the battery pack and the engine in front, and the total weight of this plane with pilot is 450 kilo. So it's a very light plane with a lot of power, and we used Formula One batteries that has extreme rate of sea rate to discharge. It was the world's fastest electric plane in its weight class when we flew it, but we didn't make an official world record with it. So why am I here and doing a seaplane? How many of you have been in a seaplane? Can I see some hands? Okay, that's like 2% of the audience, and we want to change that because you probably know that 80% of the world population live by the sea. So in any country that has shore or lakes, there will be people living beside the lake, the river, or the sea. And the seaplane can utilize that as an infrastructure. So in the past, these planes you see on the screen are super old. This is why it's hard to make money with seaplanes. They corrode, and they're old and have a very high maintenance. The Maldives is the biggest market in the world with around 150 to 200 seaplanes operating, primarily Twin Otters and some Cessna Caravans. And the Twin Otters have an average age that is really old, pushing 50 easily. So we think it's room to do innovation. So in 2021, Thomas made the first drafts of the subscale and the flying boat design that we chose. And in 2023, we launched the Noemi. Noemi stands for no emission and is amphibious aircraft. So you see there is the wheels, so we can take off and land on a runway, but we can also do operations on water to water, water to runway, and runway to water. And also airport to airport, if you want to. It's all about the use of the plane, and I think we can address almost all the business cases of the eVTOL. So why do we build a flying boat? Because the Twin Otter that you see here has the huge floats, the big floats that creates a lot of drag. So it has a lift over D, which is the technical thing about how much air resistance you have, of around 8. Our plane would be around 16, which is good, because then you use a lot less energy. And that means that you can actually do a battery electric flight, because seaplanes fly short, low, and slow. And what are we trying to do now with the IP of the company? We're trying to recreate like a twin otter on top, and on the bottom, a Grumman mallard. So it's a flying boat design, and we are the first one in the world now to try to address this in a really good matter in the commuter class segment. And we did this summer. As you see, the subscale is quite big. The drones outside you see on the lawn are the same size that this one. It's 4.5 meter wingspan. So you saw in the video this one, you can't really see it, but it's a big, big drone in many ways. So we had the test this summer and did some iterations. And on the table in front of Thomas, there is a model that you can come and see if you want, and that is the latest iteration of the design. So these are the metrics of the plane. It's a CS-23 level 3, 9-seater, 2 pilots, certified for single pilot operation, 1,000 kilo payload, a range of 1 hour flying, and that will cover a lot of what seaplanes do today. These are the business cases we can do. So we can do the VIP transfer, you can do cargo, medical, and then you can have different class of 9 sets of passengers. And I say to the team all the time, and I will repeat this now, we have to love the business case and like the product. So we have talked to all the seaplanes operators globally that operate, and we have tried to make a plane that they really would love to use. So to give an example, in the north of America, you have 1 million passengers traveling with seaplanes from Vancouver and Seattle. And this is actual existing markets. In the Maldives, it's around 2 million people traveling with seaplanes every year. I think the biggest operator in the Maldives transports 1 million people. And if we can cut costs for them and service their market, we have a direct customers. So we have sold around 70 of the Noemis as a memorandum of understanding, doing soft order for this. We want to achieve more metrics out of the test of the prototype full scale that will fly in 2027. So we're starting producing it now. These are some of the markets. We have orders in Scotland, Greece, Denmark, Panama, and Cambodia, and also in the US and Florida. But we have no partners in China yet. And that's why we're going to Aero Asia in Zhuhai next week, and we will meet there together and see if we can find good partners for China. And this is an example, because we are going to Zhuhai, and if you take the Great Bay Area, you would see that there is a lot of traffic going there, and everything is going around the water. So there is actually a big market here, and I think that we can do it better than the eVTOL. This is an example if you go from Guangzhou to Hong Kong International, and this is a fixed-wing flight, certifiable today, nothing strange you need to do. It's a very conventional plane, and you could land in the sea outside the international airport and walk in like the ferry. And you would save a lot of time. I did this travel myself 3 weeks ago, and I used a train, but you use a lot of time to get to the train station, get further on, and there is a huge river going to Guangzhou. And since we don't need big infrastructure, as you witnessed in the great presentation from Autoflight yesterday, to put things in the water is an excellent idea, because you don't use premium real estate. And if you have a successful floating airport like we have, then you can put down another pier and you could land and dock 3 more Noemis without any big cost. So we think we can do all the business case of eVTOL with fixed wing to locations that are near the water without the high cost of a vertiport, because we put it in sea. So, key takeaways for you guys: 80% of the world population live by the sea. I say that 70% of our planet is a runway, so we can use it, and it's free of charge and very accessible anywhere. It's electric, and that's how you can get the cost down and make the unit economics better for the operator. And you can use this both as VIP transfer, but you can also use it for regional islands in Indonesia and places where you have a big need for fast connecting infrastructure, and you don't need to destroy valuable land to build an airport, so you would save money. So who will be our partners in China? We're open to discuss and find out the potential together. And if you're going to Zhuhai, meet us there. We will be together with our Cambodian partner. And yeah, from the fjords of Norway to here, I think it's a lot of possibilities for seaplane, and I would be happy to talk to anyone after this presentation. So, thank you. And last, I will just say, for any questions, I will give a poster as a gift to the seaplane questions in the panel, okay?
Hello, and stay up there because we are coming to the panel right away. How many chairs do we need? Maybe you tell. Yeah. How many chairs? I have to check. Six chairs. Six.
哎，你们拿那个6把椅子，6把。Yeah, nice. Yeah.
So please, all speakers of the session come up again. So Tian also and Liu Xiushuan.
咱们那个中方的那个演讲者，咱们一起上台吧，一起交流一下。我看谁要那个刘方国呢？刘方国那个谁樊新月在吗？
So if anybody of you has a question to this gentleman or to the other aircraft which were there, there is a first question there in the back.
这样，你们那个如果要提问，如果看不到，最好到这儿来啊。
Yes. If you have any questions, please stand in the front row.
Because we have quite a lot, you can come up to the microphone and we can
有问题的要提问题，咱们下边可以到这儿来，我们由这儿来提问。
Seems to be that the other two are not here, so I think we start. If they are still coming up, that's fine. So you want to ask the first question?
Yeah, first ask the question. Yeah, okay.
So you have your translator?
Oh.
Good afternoon, Eric. This is Jennifer from Street Aviation. I'd like to ask you a question. As around 2040, some traditional aerospace manufacturers, such as Boeing and Bombardier, had already frequently exchanged the eVTOL concept and within the factory through forms like professional sharing. When did your company first capture the signals of this emerging field? And based on what considerations, such as market potential, did you decide to commit to practical implementation?
Do you ask about if the seaplanes are practical application and the market?
I mean, based on what considerations that your company tried to decide to do the practical implementation to this field?
Yeah, so I'm also an investor, and I'm also an early investor in some electric aviation company. And I was looking at the eVTOL market and the struggle they have with battery technology and flight time and useful load. And I'm also a pilot, so I thought that the fixed-wing approach was a good thing. And then it's hard to access the city center where the people are and where you could go. And together with the collaboration with my brilliant CTO Thomas, we looked at the seaplane. And it's a niche product, but it's richest in niches. And I think it's an under-innovated market. And I think it's not a market for like Airbus or Boeing, but for a company like Embraer who produce smaller planes or Textron, this could be a brilliant product. And we want to bring it to market to operators that are doing air taxi and seaplane operations. If that was a good question, ask, and I mean.
Maybe I want to know the a specific time, like which year you decide to join this field?
Yeah, it was around 2020, because there was a lot of interesting stuff happening with eVTOL, and I think it's a brilliant market China is addressing in a great way with the lower sky economy. But I take my approach from Norway and the fjords and the waters. That's why we ended up doing a seaplane.
Okay, thank you for your sharing.
Yeah, so ours is your picture. Yeah, 说这儿，送你一张图。
I can give it to you afterwards. Okay.
Okay. Okay. We're waiting for other questions from the audience as we still have some time. Would like to know, because the MD aircraft and Eric's aircraft, they are pretty similar. Like, you both have 9 seats, you both have 2 motors. You both are heading for a commuter market. So would MD aircraft also consider having the aircraft on floats?
That's not considered yet.
Not considered yet. Okay.
Maybe some more to this. As Eric has pointed out, if you put land aircraft on floats, you create a bad aircraft. So I don't see it for the future.
Okay. Question to Smart Flyer, to Rolf. The aircraft you're designing, are you also thinking of maybe having a family of, like, we could see an MD aircraft having the next and the overnext step already having a larger version, maybe an 8-seater commuter aircraft with the same kind of design? Or would you say, no, I think 4 seats stops more or less there?
Absolutely. We have already done some studies about the 10-seater with the same configuration, the main propulsion system on the vertical tail. In addition to that, some smaller electric motors on the wing tips. This is only to reduce the induced drag. We can gain like that with these motors on the wing tips about 5% in efficiency, and that means we can additionally reduce the size of the vertical tail, the rudder, because during the cruise flight you will be able to steer the aircraft with asymmetric thrust on the wingtip motors. So these are just studies we have done. In the first step, we are concentrating on the 4-seater. 4-seater is for the commercial pilot training market, which is a stable market. And when you believe the forecast of Airbus and Boeing, within the next 20 years, the demand for new pilots is about 600,000 new pilots. That means they need a training aircraft, and the market is very promising for training aircraft.
Okay, thank you. Eric, one question for you. In the former years that we heard about you, so maybe it's by purpose, you talked a lot about the Norwegian use case, because that's where you come from. Can you tell us a little bit where you are there? Is this still the first market where you want to be on the market, or is it that as a Norwegian seaplane also could be that your first use case will be somewhere else and not in Norway?
Yeah, as I said, we have some MOUs for sales of airplanes, and they're very global. And as I am also the main investor in the company, I'm a businessman, and I say they need to pay up. So if the Norwegian government don't step up to their words of zero-emission aviation, we will probably launch in some other country first. But Norwegian government has said they will do it, and there is an effort now with something called Test Arena, which is an international test arena, and Beta is flying there now. And they had international quotas, and also Chinese companies could apply for these, but there's probably a huge barrier. But if you talk to us there is potential to test your aircraft in Norway because it's an international test arena funded by the government.
Yeah, I talked with the folks of Beta, which are flying right now. This would be the next question, actually, with the Beta. Don't you think maybe you come a bit late then, because the Beta already started flying now, maybe they could be in service later, or would you say, no, we with the water use case are so special that we will be best for Norway?
I think it's two different things. Beta technology, the plane they fly now, need a runway of 1,100 meters. And we don't need a runway. And that's basically also into the business case, because if the Beta machine has 5 seats, and you need to pay for landing fee and handling fees and parking fees, it bites off the cake you want as profit. So if we can use the water and don't have to pay landing fee and all that, it's a better business case with 9 seats. So yeah, slightly different.
And just the last one on this water use case, because I remember when I'm being in large cities on water, you normally always also have a lot of boats driving around here. And then if you come to land, how do you assure that you have a safe landing place in this area? Do you have to block some part of the water at the water runway, or how would you get away these boats?
Yeah, this is a great question, and we get that a lot. And usually I show a video from Vancouver where they land and there is a lot of boats. And what I would say is that this would happen together with local authorities. And in some cities, some places like New York, you have a seaplane operation, and they're not restricted, and they don't serve a specific part of the river, and they go in and out. And yes, they have to pay attention, but once the plane has landed, and they use really short distance to land when you land in water, because you take out the energy quite quick. So then you're a boat by any kind of rules, and then you just follow boat rules and dock to the harbor.
Okay. Any question from the audience? Yes, here. Okay.
Question to Eric. I don't have time to change with Carl, and we just stop later on. But question to Eric. You talk about you're looking for partner in China. What kind of partner you're looking for?
We are open to find good partners that could buy the planes and operate them in China. That would be a very interesting thing. It's also about parts. On my board, if you saw the video, Susan Ying, which maybe some of you know, she is on my board, and she's in China also, and she will be at AeroAsia. And we are discussing potential production and things like that for the future. But this is a long-term relationship, and we don't need it today.
Thank you. Okay. Our question from Scott.
Thank you. So Eric, you're the lucky winner for another question.
Everybody wants a poster.
Oh, yeah, he's going to run out of posters, but I can't take one back, so you can save them. I'm curious. It's obvious with your market plan that you've got, you're maximizing your number of operations per year because you can do water to water, water to land, land to water. Do you have? I'm curious about the sea state. How high of a sea state you can take, and does your hull allow any more of aggressive water operations than the conventional boat planes that are being operated now? And does that then affect your usefulness or your total operations per year?
This is a great question, and this is one of the reasons why we're building a flying boat design. Because as Carl points out, the planes that you see with the twin-otter on floats, that's a land-based plane, and somebody removed the wheels and put floats on them. It's a really stupid idea. You would never do it to your car, but you do it with planes. And this is why the flying boat design can go in and out of much worse sea state, but this is about passenger experience. You can take off and land safe, but it will not be a great flight. So we know that we try to achieve a certification of 75 centimeter waves, and that's quite a lot. We know that we might be able to do even more, but it would not be pleasant. But one of the things I would point route, if you fly in a lot of the locations we look at, you fly within islands and things which are not heavy waves. But you could do emergency landing in really heavy water. And if you look at things with SARS or search and rescue, there could be configurations of the plane, both military and search and rescue, that would be excellent because you want to be safe, not pleasant in a way, if you understand.
Thank you very much.
Okay. So I would have an additional question for Rolf. With the smart flyer being around quite a while, and you think you're gonna also look for other motors? Because if I look, let's say, at a 4-seat plane and then look what horsepower is at the moment mounted, then you would rather be at the lower end of the, okay, if the aircraft is efficient, but would you, for example, look also for a larger electric motor for the aircraft to be in more capabilities, maybe even short takeoff and landing?
We use, or we have chosen after the first test with Siemens and then Rolls-Royce, the SP250. They gave up, unfortunately, and then we have chosen the MRAX as a test motor. And for type certification, we need then a certified electric motor. This could be a Safran or whatever we have then available on the market as a certified electric motor. The power of 160 kilowatts should be sufficient. Maybe we can increase that, but I think for short landing, takeoff and landing aircraft, maybe the configuration is not optimum because of the thrust is not flowing to the wing. So you cannot increase the dynamic pressure on the wing with the thrust. This is just missing compared to the
distributed propulsion.
Yeah, for example, where we really use this increased dynamic pressure on the wing, and that's the difference. I think it will not be a perfect or an optimized short takeoff landing aircraft.
So what takeoff and landing you're looking at? Takeoff distance?
The calculated takeoff distance are comparable to a traditional aircraft, between 400 and 500 meters.
Okay. Question to Carl. Where do you think, you mentioned some, but where do you think the first aircraft will be in operations? You have some people, or let's say island flyer, who say, no, we want the first, we want to fly, and we want to fly 2029 or 2030, or is it also still open to first come, first serve?
Theoretically, first come, first serve, but practically I expect instantly for OFD, just because it's next to the production.
And manufacturing-wise, later, as we all know, German labor costs are not the lowest on the planet. Would you consider, and I know that you traveled a bit in China, would you also consider having, let's say, either contribution of composite manufacturer or maybe even the whole frame, airframe, produced in China? Or would you say, no, at this point you cannot decide on such things?
At the moment, two concepts are followed for the series production. One is increasing automation on composite production, which is a delicate thing, yeah, with the low volumes and yeah, the investment costs. But this is the one path we are looking into, and the other path is, of course, offshoring. Yeah, China would be a possibility, or also some South American countries.
Again, question to the audience. Any question here?
还有问题吗？咱们下面的听众 ，question?
No. And
Okay, also here, question from you.
No. I just say that it's dinner time soon, so I think people want to go.
Yeah, right. We stand between them and the dinner, that's true. But I enjoy this. No, the thing is, I still have some details which I would like to know, because that's why we came here, not for the food, as well.
Sure.
But question on the battery side, like all three of you, with which battery capacity per kilogram you calculated your aircraft? Your aircraft is profitable, working. So what is the minimum, or what is you should have, and what you expect to have in, let's say, 3, 4, 5 years when the aircraft will be finally on the market? One by one, I would say. Carl, you can start.
260 watt-hours per kilogram.
Okay. So unfortunately, I have to disappoint everybody here, maybe because we have not a very high capacity per kilogram. We have only 160 watt-hours per kilogram, and that's the reality. But it's an almost certified battery. That's the difference.
Okay. And I can say that I don't know the exact number, but what I've told the engineers and what we're working after is that the batteries you can buy today is the batteries we are making the plane from. And that means that I want, as the investor, positive risk, because the batteries are not getting worse, they will get better, and that will add to the product. So I say that we have around 1.5 ton of battery-ish, and it's around 400 kilowatt hours in that pack-ish. But that's numbers to be changed. It was on the slide.
Okay. Maybe we don't want to be too cruel, so maybe a last question. So you have time to think about one more question while I ask a question here. So hybrid. Carl, you showed that there could be a hybrid option in the aircraft, but I suppose fully electric will come first, or will you think also if there is a demand for longer range, start with a hybrid version?
Yes, the concept is definitely to have the full battery electric version first, because we have one less system to design and to certify. Okay.
And Rolf, you showed us the version where you have the rotors in the nose. So would you also go for the certification of a battery first, or do you think you go with the rotors in the beginning?
We will go for the hybrid version at the moment. This is installed in the prototype and ready for testing. But for sure, we would appreciate to have just the battery electric aircraft. It's much simpler. You don't charge the batteries in the flight. This is an additional system you could fail. But unfortunately, the battery capacity, the specific energy in the battery is just not enough. And the performance is not enough to have just a battery electric aircraft.
Okay.
Yeah, we are doing a clean sheet design plane. So we want to keep the option open, and I'm an investor that wants positive risk. So we designed the plane to be capable of having a hybrid system or Jet A1 and normal fuel. And that is because we want several application possibilities open for the plane, and we do not work on the propulsion system ourselves, and we want the customer to be able to do the choice. But I would state again that the normal seaplane trip is like a 30-minute flight today.
And one question, when you now said Jet A or other fuel, it's still hybrid. It would not be that you would put a turbine into the aircraft and then fly with two turbines, or is this also an option?
This is the interesting thing, because we designed it around some electric engines that were in design to be a retrofit for a PT6. And then I was discussing with the team, and I said, if the business case for this engine, which is electric, is really to be retrofitted to a PT6, then it means also that we could put the PT6 on the plane and it would perform. So if we are a bit smart, and Thomas is a smart man, we reserve space in the wing for fuel tanks, and then you have a normal plane. And then you could address the firefighting, you can address the SARS, search and rescue, and you can address the military one.
Always a more modern plane than the existing seaplanes.
And that's the thing. Nobody can bump the runway. You can go in and out where you want, and you can have a very flexible, small, light plane with approximately almost 2-ton useful load.
Okay, now really last question. Same to everybody. What about fuel cell, hydrogen? Do you believe that there will be a hydrogen use case in the, let's say, near future, let's say the next 10 years, will be available at the airfields? And are you designing fuel cell solutions also for your aircraft? Let's start with Eric this time and end with Con.
The answer is no, because there is a famous saying that hydrogen cars will always be the car of tomorrow. And I think that the business case, it was kill hydrogen. It's proven it works physically. You can do it, but the business case is really bad. And the business case is more important than the product. And I would say, if you ask me what's the alternative, I would say synthetic fuels. And then you would say, but it's too expensive. But the good thing about synthetic fuels is if you have a low cost of energy, you could produce them and transport them in a normal truck and put them on a normal plane because it's Jet A1 of the purest quality. And that's much better than hydrogen because you don't need a new airplane, you don't need a new fuel system, you don't need a new tank truck. It's just about the cost of producing the synthetic fuel.
So you invest also in producing of synthetic fuel?
I think I would, rather. But there is a great thing with collaboration in Norway with Boeing, that they have a factory for synthetic fuels in a place where it's hard to get electricity out. So they can produce the fuel and actually move it.
At very low cost. Okay, so Rolf?
Yes, I would say hydrogen is a topic for CS25 or 25 aircraft airliners, and they need to provide the infrastructure of hydrogen on the airports. And for smaller aircraft, I see the problem with the availability of hydrogen infrastructure on small airports. That's something which will be difficult. But as you have seen in the slides, we are open for fuel cell integration, and depending on the availability of hydrogen. But we are not building an aircraft in 10 years for tomorrow. We are building an aircraft which you can use today. Today, on every airfield, on every small airstrip, you should be able to fly with a smart flyer.
Okay.
Yes, I can say we are also not designing an aircraft for hydrogen application, but I am a believer because I'm an engineer, and also because of my other company, we are doing a hydrogen fuel cell project. Yeah, when I was here in Kunshan at the lake yesterday, I saw some scooters that were operated by small bottles of hydrogen. So I find this very interesting, and I'm just leaning back and waiting to see if the hydrogen supply topic will once be solved or not.
Okay, thank you very much, and thank you all for being here. Thank you for listening and staying that long with us all. And yeah, see you tomorrow for the rest of the program.
And thanks for a great conference.